Okay.
Okay, then good evening, everyone. Welcome to the third day of the webinar series on opportunities and challenges in engineering education. Today, we focus on mainly uh, space science and avionic engineering, then architectural engineering, then aeronautical engineering, and finally, chemical engineering. And so we have the first speaker regarding the space science and avionic engineering, an eminent person, Dr. Chinmay Saha. Let me introduce him. Dr. Chinmay Saha received his BTech, MTech, and PhD degrees in radio physics and electronics, University of Calcutta, India, 2002, 2005, and 2012, respectively. He is currently working as an associate professor in the Department of Avionics, Indian Institute of Space Science and Technology, Trivandrum, Department of Space, Government of India, and visiting Royal Military College of Canada as a postdoctoral fellow. He was also associated with Jadavpur University, Kolkata, India, as a visiting faculty from 2008 to 2012. He is a member of the IEEE since 2006, promoted to senior member grade in 2014, and served in various positions in IEEE APMTT Kolkata chapter and IEEE Kolkata section. He is also a life member of IETE. Currently, he is the chairman of the Antennas and Propagation chapter of IEEE Kerala section. He is a recipient of national scholarship from the Ministry of Human Resource Development, Government of India, for his excellence in BSc Physics honors, the University of Calcutta in the year 1999. He also received the Outstanding Contribution Award from the Antennas and Propagation and Microwave Theory and Techniques chapter IEEE Kolkata session in 2010. He was awarded the Best Contribution Award for notable services and significant contribution towards the advancements of IEEE and the engineering profession from IEEE Kolkata section in 2013. He has more than 60 publications in peer-reviewed national, international, and conference proceedings. With these words, I welcome you, sir, to the session.
Thank you very much, Dr. Rafael. I don't know whether I sent a wrong short CV or you have got it from somewhere. There are few factual errors. I'm not the chapter chair of antenna propagation now. I was former chair during 1890. Recently, we have started the micro theory and techniques chapter, for which I'm the founder and arranger. Anyway, so at the outset, let me first thank the IEEE Kerala section for organizing this beautiful event for youngsters on this engineering education and opportunities. The way it is planned is really good because there are multiple speakers on multiple panels on multiple areas. And special thanks to Professor Muhammad Qasim, who has invited me in this particular virtual podium. So I'll go to the agenda. And as we know, especially the IEEE Kerala section, from statistics, we know that we have almost sometime close to 10,000 members. Maybe due to the pandemic situation and different other associated obstacles, might be a little bit less, but still we have a pretty handful number of members, and majority of our members are very young students, I mean the BTech students. So for them, definitely they have joined IEEE, they are doing engineering with a lot of hope, but to know the clear career journey in terms of all possible avenues, starting from job as opportunities to higher education opportunities, or some of the new concepts or new buzzwords that are being used nowadays for motivating youngsters in terms of incubation or in terms of startup. So those five things all depends on the technicality, all depends on the curriculum, all depends on the fundamentals that we learn. So in this particular talk, sorry, I'll try to enlighten the youngsters in this particular direction. And this talk will be a bit of, I can say, semi-technical because certain things will be technical because when I talk about the opportunities, naturally, some technical fronts will come into picture. So with this, let me share my screen and take you to my slides. typically there are sometimes some amount of delays. Do you see my screen now? My slide?
Yes, sir. Yes, 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 sir.
Let me go to full screen. So, the opportunities and challenges in engineering education. Initially, Professor Kasim told me to talk on the space aspect, space science and engineering. And then, due to an unfortunate situation of one of the panel members, Dr. Setuna, who is a very close associated of me because he is one of the co-guides for one of my PhD students from the SEC. So, because of that, I was requested to talk on the avionics part as well. So I'll try to do dual role. And as you know, avionics is very, very close to space science. So it's not a very difficult job for me. So these are the typical aim for me that I'm going to connect the opportunities as an engineer. And I assume that the engineer is a space scientist. I mean, having a good background of space knowledge, or he may be electronics and communication engineer, or an avionics engineer. But later on, very soon I'll be showing you that space is for everyone. You really need not be a space engineer, or you really need not be an electronics or communication or electrical engineer. Space has opportunities for everyone. So from that aspect, I'll be covering the higher studies aspect because as you know, after our bachelor's, definitely the majority of the students are going for the job at different kind of level. But at the same time, there are a handful number of students who are going to premier institutes for higher education, masters, because in especially in outside, these higher studies is also considered as a job because their salary or stipend, whatever you call, that is good enough to maintain a healthy life. And even I have seen many master and PhD students, they start their conjugate life during their higher education. But in our country, the stipend or salary might not be that high, but still now the PhD salary is pretty high, like it's almost 30K for SRF, GRF position, which is more. So that can also be considered as a kind of semi-partial job. And then from higher studies also, we can go to the job probably with a better job, with a better research mindset because you get groomed. And then nowadays, the government of India and through different other initiatives of DST, Department of Science and Technology, the startup and incubation is very much promoted. There are various institutes, especially the national institutes. When I say national institutes, I mean the IITs, NITs, all national universities, etc. And some of the leading private universities are also trying to come up there with their startup and incubation center. So whatever a career goal we take, whether we initially go for higher studies and then come to this type of initiative, startup or incubation, whether we directly go to job or come to a job after a higher education. So higher education means it can be masters, MEM, it can be PhD, it can be, you can go to for MS also in abroad, those kind of terms are also. So this is very much interlinked, and whatever you do, the basic remains same. You need your basic to be very strong. So this presentation, I will try to cover all the aspects of this, and I know I have another 25 minutes or so. So when we talk about the space science or space systems, some people think that initially that I have to be an astronaut or I have to study with the space engineering like that. Actually, no. If you see the broad perspective of the space, of course, it's like an all-rounder. You need to be good on everything. But if you see the manpower requirement in a typical space system, we need electronics engineer, we need electrical engineer, we need computer science, we need physical science. When I say physical science, it's basically it's just not physics. It is physical science means it's physics, it's chemistry, it's material science, atmospheric science, everything. Then art science. Under art science, as you know, there is recent focus is increasing on art science because of new coming applications in the areas of remote sensing, climatology, climate sensing, etc. So on and and so forth. And nowadays, I'll show some of the interesting slides that the UAVs and then different kind of applications in wireless power transfer for powering the UAVs or solar cell, etc., are also coming into picture. So that is very much interrelated. And another wing is of course aerospace. And each of these 6 wings that I am showing, it is very broad. So each of that can be further divided into specializations. So when you are joining any space agency or uh, any government or private, typically in India, space agency or space applications, when we talk about from the government perspective, the major intake is at ISRO and almost equal in the RDO and some other government positions. But now private industries and startups and other things are also coming up. But as a BTech or just with UG degree, if you join, so you will not be, of course, you'll be joining in some of the disciplines. So then you're actually, even though you're a scientist, your learning, practical learning actually starts after you join. So as an electronics engineer, if you get a job in a space industry or I say ISRO, you'll be deputed in certain center in a certain division. So that division might be doing some microwaves or maybe antennas or signal processing or maybe communication, payloads or anything. So there you have actually, when you are you are tagged as a scientist, actual learning starts there. So for each and everything, I'm talking from electronics aspect. Similarly, if you go to computer science, because you know there are different national remote sensing centers, and then there are other kind of centers where the satellite data is received, and that data needs to be processed to get the actual data, which is being sent by the satellite transponder. So there are different issues like data security, networking, system, etc. comes into picture. So again, as I said earlier, so your actual learning process starts from there when you get the practical data, use data from the satellite transponder, which is received at the ground station. Similarly, physical science can be further divided into optical engineering, astrophysics, atmospheric science, etc. So that's what I said at the very first point, that space gives almost equal opportunity to everyone. So it is our duty to make our fundamentals strong and harvest those opportunities and build our career accordingly. Like, sorry, if you see the typical organizational structure of space as far as the government of India is concerned, as you know, Department of Space, which is almost analogous to Indian space research organizations, even though there is a tiny difference, is directly under Prime Minister of India. So under this Department of Space, we have some autonomous bodies which are PRL, Physical Research Lab, NARL, NESAT, SCLs, which is Semiconductor Lab, one of the major foundries in India as far as the microelectronics and the clean room facilities is concerned. IIST, Indian Institute of Space Science and Technology, my institute, is directly under Department of Space. And then ISRO is the biggest, rather for all of us. Under ISRO, we have so many centers starting from BSCC to LPSC to SDSC SHAR, then ISAC, TAC, etc. And then in between this PMO and Departments of Space, we have Space Commission. So this geographical structure and this organization structure is very important for the job seekers as well as the young engineers, because you need to get a clear idea regarding the different opportunities, different centers, etc. And as you can see, I was talking about the organizational structures, and here you can see the spatial distribution of the opportunities across the whole India. So you have almost all corner of India. There are some direct or indirect units of the Indian Space Research Organization. So starting from the southern part to northeast to western part, everywhere it is there, and there are certain units which are specialized on certain things. For example, if you talk about the payloads, if you want to work on antennas, if you want to work on millimeter waves and terahertz, and you want to design the payloads for satellite applications, you should try to get a job at SAT Ahmedabad, Space Application Center. Similarly, UR Rao Satellite Center is another dominant center where the communication, networking, and the antenna work also happens. But as far as the Trivandrum and the Kerala is concerned, we have so many centers over here. One of the oldest units is the Vikram Sarabhai Space Center, then LPSC Liquid Propulsion System, and then we have a very close from, I mean, very nearby from here, that is, Sriharikota, which is near Chennai. So these are the typical organizational structure. So, I mean, next part of my presentation, I'll spend around 10 minutes on the next part. I'll be talking a little bit of technical because I try to mix the technicalities with the opportunities, because that to me makes more sense, because then only you get the better idea, because otherwise my job will be like a managerial talk, which I don't want to do that. So what I want to mean is that, the spectrum, when we say about the spectrum, we describe in terms of the megahertz or gigahertz, different buzzwords like 1G, 2G. Now people are talking about 4G and 5G communication. So these Gs or generation are nothing but the technology development, and this technology development is heavily dependent on the frequencies and spectrum allocation. So when you see from that perspective, I say the spectrum of opportunity is enormous. It is from megahertz to terahertz. So as an engineer, we need to know what is radio waves, what is microwaves, what are their typical applications, whether high frequencies are good or mid frequencies are good, what are the satellite bands, what are the the AM bands, FM bands, radio bands, and everything. What are the frequencies for which the terahertz is being talked about, the millimeter wave are being talked about, the new generation 5G, 4G communication, especially the 5G technology. What are the spectrums that are being considered? If we get an idea, then at the early stage we can focus. At some students I have seen from my teaching experience and research experience and mingling with the students, some students are very much focused. They're at the very early stage of their curriculum. They decide they want to do this kind of work. So I encourage those students to start their internship work or some extra work beyond the course at the early stage. So some of the students start working in the third or even fourth or fifth semester, very serious work. What happens is those students, because of their extra focus, they come up with a very good BTech project work. And from those project work, sometimes they come out with some quality publication. That makes a lot of difference when you especially try for a higher education, right? So this, as I mentioned, is megahertz to terahertz. That is the spectrum of opportunity. So depending on your application, especially from the communication perspective and the space perspective, if you can have a clear idea where you want to focus or where you want to land in your career, that would be very, nice. But of course, everyone cannot do it. So you should see the full picture also. Then you probably can take a call. And then, as you know, that NASA and ESA, and of course our ISR also now are talking about the terahertz communication, because terahertz gives the fastest possible link, the highest data rate. But the problem is the attenuation is very, very high when you move to the higher side of the spectrum. Then why we are talking about this? Because this concept of attenuation comes when the wave has to propagate to a conventional media. But if it is a space communication, perfect space scenario, that means inter-satellite communication or intra-satellite communication, or sending a very, very high data rate for a very near field or near range applications, then terahertz is the best. That's why, in spite of so many obstacles, terahertz is being given a new thrust and new rule, and people are trying, especially the space agencies, are trying to target the different bands of terahertz. So this is the range of frequency which typically we call about terahertz, 100 gigahertz to 10 terahertz. So if you want to land your career in this particular domain, you have to definitely work with the space systems. And at the very beginning of your career, you need to have a clear idea on the VLSI process, fabrication, materials, etc. Because when you talk about 100 gigahertz, all the devices, your circuits, your amplifiers, your antennas, everything will be coming in the nanoscale. So the solid understanding of those things will be very, very important. On the other hand, suppose you are trying to target for some kind of observation, some kind of experiment, suppose sorry, you want to do some kind of spectroscopy, then you need to have a clear idea on impact of the atmosphere on the electromagnetic waves which are coming from celestial object. So this is a distribution, a very nice picture which is available in the NASA website. So you can see the different frequency bands, like this is gamma ray to X-ray, and so this is the lower side of the spectrum, and this is the higher side of the spectrum. Fortunately, the atmosphere is very friendly, and that's why these high energetic rays, gamma rays and X-rays don't reach to us. The visible rays, as you can see, is reaching to us. So you want to have a radio communication, satellite communication. So based on this kind of structure, you have to define the frequency bands. And if you want to do some kind of observation regarding the X-ray spectroscopy or gamma ray spectroscopy, you can get an idea, because these rays are not reaching to the surface of the earth from the celestial object. So you have to go above to do the experiment. So when you want to go above the experiment, obviously, what are the mechanisms? I have a slide on that I'll be showing you. So this is a typical idea on the different frequency band allocation. Like as you know that L, S, C, these are the some conventional bands at which the satellite communication takes place, but the future bands or the upcoming bands, the KU band and Ka band are also taking place nowadays. Because I, closely work with some of the ISRO centers, so now I can probably share some information that now because of the higher data rate demand, we are also thinking to move to the higher side of the spectrum. Not only that, we are thinking to receive the data in multiple bands. So S band, X band, and Ka band, all these things are being considered together. As I mentioned, if you really want to do some type astronomical observation type of experiment regarding the X-ray or the gamma ray observation, you have to go above the climate. So if you want to really do that kind of experiment, either you have to have a sounding rocket type of experiment at Vikram Sarabhai Space Center. Such a facility is there. Then you can have a balloon. Inside the balloon, you can have different kind of payloads. So these balloons are special balloons which can, go up to a few hundred kilometers. So you go above the atmosphere and you can do different kind of experiment, and then you receive the data and then you come back. And of course, the largest technique or the most prudent technique is the satellite based application. So when you see this kind of structure, I mean, if you just think a little bit in detail, it is, even though we talk it's a communication, because I'm receiving some data from the Earth station or from the satellite, and I want to send it to the ground station. If you see the overall system, even though it's a communication, it's a data transmission, it requires antennas, it requires circuits, and etc. But the scope is enormous because it involves so many things. It involves the structure, it involves the onboard computing, it involves the materials, it involves almost everything. Solar panel to have power getting harvested from the atmosphere itself. So it requires different set of skill sets and different kind of engineering knowledge to develop such a system. That's why I mean that some people think that the electronics engineers or computer science engineers are having the highest opportunity. No, if you see the full spectrum with a full horizon, actually there is almost equal amount of opportunity for everyone. The material scientists, the aerodynamics people, the aeronautical people, everyone have almost equal kind of share. So before I go to the last part of my talk, I just thought, because for the youngsters this slide will be very, very interesting, because as you see the launching mechanism of a Chandrayaan-1 mission, that is from the initial orbit, which is the geostationary transfer orbit to Earth orbit, and then how, as the lunar's position, the position of the moon is also changing. So how finally it is getting synchronized from the initial orbit. As you know, this is called the perigee. At perigee, you give a extra kick. That's why it goes here, and then you give another set of extra kick. And finally, in this process, your satellite finally, goes around the moon, and then we call it a successful launch. So if you see the entire launching system, so much of money, so much an involvement, and so much of media attention is also involved. But it ultimately requires the multiple skill sets from almost all kind of engineering and branches. That's why I always say that space gives almost equal amount of share to everyone. Okay, so this slide courtesy goes to the the ISRO website, and then you have launched the satellite. Next comes how do you receive the data. So in this slide, I do show two different kind of data reception. One is the natural data which is coming from the celestial object, as many of you might be knowing that we have different kind of radio observation. That is GMRT, which is giant microwave radio telescope, which is at Pune, Maharashtra. So these are some dish antennas. The radius of these antennas is 45 meters. So these antennas are receiving data from the space, of course, for atmospheric studies. Whereas this is also a dish antenna, which is also receiving data, but this is with a different kind of purpose, because this data is being sent by the satellite transponder, and you are trying to receive this data. So this is a facility which is available at National Remote Sensing Center, Hyderabad, and this is a facility which is at Pune. So these antenna receive the data from the satellite, and at the same time, we have to ensure that the satellite antenna and the ground station antenna, these two antennas are looking to each other. If they are not looking to each other, then the ground station antenna will not receive the data. Then what it requires is, it is not only antenna, the servo system, the motor, the control. Because if the antenna is looking elsewhere, you have to do a change in the azimuth or elevation angle to adjust the antenna properly. So it requires a lot of control engineering. It requires antenna science. It requires material science. It requires aerospace. Then only you will receive the faithful data from the satellites, right? So this is this is also a satellite-based system. And as you know that when you deploy your satellite, then there is a lot of process involved in the integration. So if you see the integration process, you see how much packaging, how much care has to be taken, and how many tests are needed. Because when you want to say that my system is a space qualified system, the normal engineers and space engineers difference comes over here. But you, before launching, you have to ensure that all the components are space qualified. Space, what is the meaning of the space qualified? The component should remain equally operational in different kind of adverse condition. It may be different kind of temperature variation from some negative -100 to some few say 700, 600 degrees centigrade kind of thing. Then pressure fluctuation, then humidity fluctuation, and of course, most importantly, the vibration. So with all these things, your electronics, your system, your chip, your computer, everything, onboard computing system, power system, everything has to work. So that's why the extra challenge is needed. So this particular picture, which shows the integration process before launching the AstroSat satellite at earlier, it was now it is called URL Satellite Center, right? It is at Bangalore, and this is a similar kind of system. Up the satellite goes up, and then the solar panel is unfolded, and the antenna is also unfurled. Then it is the similar kind of structure, and you can see so many systems, the telescope, the different kind of payloads, different kind of sensors are involved. So if you see in totality, starting from optical to mechanical to aerospace to electronics to computer scientists, everyone has equal amount of opportunity in that space. And this is a kind of nano satellite. I'll come to a little bit of in-depth on this nano satellite, because our institute at IIST has a very focused mission towards the nano satellite launch. Typically, the advantage is it is less size, lower prices, and shortened or even very fast development, of course. And these nano satellites are very lightweight, and depending on the lightweight and the size in terms of one U means 1 unit. 1 unit corresponds to a 10 centimeter by 10 centimeter by 10 centimeter. So depending on the number of units you embed together, you can have mini satellites to micro satellites to nano satellites to pico satellites, and so on and so forth. In India, IIST is the pioneer in this nano satellite mission, but some of the IITs like IIT Chennai is also doing. We have some very strong collaboration with the University of Surrey and JPL, Caltech, NTU Singapore is also doing work. We are also in touch with them on some of the things. Australian National University, University of Toronto, with whom I have talked on certain aspects of this nanosat mission. In fact, most of them are using ISRO's launching pad and launching mechanism to launch their satellite. And when you see the nanosatellite part, I mean, of course, I welcome you to write to me and to our nanosatellite group if someone of you are interested in this particular area. It involves a lot of engineering, and some of our youngsters, like young engineers, when BTech engineers, when they are at fourth or fifth semester of the curriculum, they start working on different kinds of units. Some people are working on antennas or the circuits. Now we are thinking of wireless power transfer also. Some people are trying to do some onboard computing, power systems, etc. And all. So from these also, from the miniaturized version of the sentence also, you get an idea that you have equal amount of opportunity. And then satellite communication or space communication indeed has a lot of applications, starting from television to telecommunication to radio networking, strategic communication, and of course the societal applications. Needless to say, you all know there are so many users for this particular communication, starting from BSNL to Doordarshan to All India Radio, strategic government users, public sectors, the dish TVs, different kind of new channels coming up. So all of them are using. I hope I am audible because it has started raining here heavily. Am I properly audible?
Sir, I think there is some voice vibration is there. Some participants are.
Yeah. So coming to the societal applications under a different kind of new initiatives like telemedicine, teleeducation, then Village Resource Center, disaster management system, these are certain kind of societal applications of applications. So if you see the pie chart of different kind of applications, communications is of course the major taker, but along with that navigation, surveillance, earth observation, remote sensing, and atmospheric studies, etc., earth science and etc., also has equal amount of priority. So engineers are taking the largest size of the pie, but the science is also having some kind of share. And this
Chinmay, just
hello.
Chinmay, your audio is slightly feeble. Can you keep your mic closer, little closer? Actually, many participants are reporting that your audio is feeble.
Yeah, and that's why actually what happened is it has started raining heavily. So I'll try to be a little bit louder.
Oh, okay. Thank you. Yeah, please continue.
Yeah. So this slide is not for the students, but this is for the faculty members. But students are the part of the faculty research and all. That's why you should have an idea that space Indian ISRO Center. ISRO has a specific project which is called the Respond. Through this Respond, different institutes are getting funded. You see, these funds goes to almost all kind of universities, institutes, universities. Sorry, NITs, IITs, and it is going mainly towards space applications, space science, space technology, and all. So many of the faculty members, or where you are doing the studies, or you just don't look on your institute, you look towards the nearby institutes also. You get some opportunities to get involved in some kind of R&D project at your early career. If I can do that, that would be very, very useful for your career. So with this, I'll come to the research opportunities because I talked on the space part, of course, and then some of the students are definitely trying to take their career towards a little bit more of academic journey. So if you do that, basically you need to know what are the different research disciplines and domains corresponding to this space and associated thing. So I have just given few indicated areas, but there are more. So geoscience and remote sensing, antennas for 5G, millimeter wave and terahertz, wireless power transfer is coming in a big way. Then we have wireless energy harvesting, power system and drive, signal processing, and the radar signal processing, in fact, is coming up in a big way. Then we have artificial intelligence, virtual reality, radio astronomy, etc. But there are more, of course. Whatever you do, whatever discipline you take, but nowadays the system engineering is very, very important. So don't just look on your area, but try to see the other areas, because at the end of the day, you have to work in a team. So even if you are doing a specific work, that your specific product has to be cascaded with other product and other equipments, etc. So the global view is very, very important. And we also need to see what is the focus of the government for the time being. So accordingly, we have to define our research statement. Of course, the young students might not have that much of, forcing, capability, but the faculty members are the pivotal in this particular case. So we have to drive our students in a proper direction. That's why I always tell you, design the component for the system. don't expect that your component will be useful for the system. It's not very confusing. So when I am designing a component, I should know what I am designing for. So then that means even though I am working on a small area, I need to know the bigger picture. Then only I can design my component in a proper way. That's why it is called a Sigma approach. So it's not the reverse approach doesn't work. So I have to know the global system. From then I will take a particular part and I will concentrate on that particular area. So that's what I'm coming to the fag end. I have probably overshooting, but within another couple of minutes or so, I'll close. So wireless is everywhere. Like we call the Kerala as the God's own country, right? We think that the God exists over here. And the EM engineers and the wireless engineers are very proudly says that wherever you go, you will get the wireless signals. Either you will have the mobile signals, GSM signals, or some kind of signals. Even if those are not there, you have the celestial objects, you have the atmospheric radiation, you have the radiation from our body also. So wherever you go, you have the wireless. So I'll just give you some more information regarding different upcoming applications of the wireless technology. Wireless doesn't only means communication or just the the radar and etc. It is having different kind of applications nowadays. So these civilian applications, military applications, the antennas which is to be worn on the body and it has to be proven by integrating on with different kind of jackets, different kind of other kind of soldiers uniform, etc. Then sometimes now antennas are being integrated inside the body or on the body for a better channel modeling and remote diagnosis, and of course a different kind of smart hospitals and smart home kind of requirement. And the new materials like different kind of dielectric materials, magnetic materials, magnetodielectric materials are coming in a very big way to help the antenna engineers, to help the EM engineers, to help the different branches of engineers. The composite material is having a very, very important role in the modern technology. So there are opportunities for the material engineers, microelectronic engineers, and almost everywhere. So, and then the new standard of communication like software-defined radio, cognitive radio, wireless power transfer technology are coming in a very big way. I wanted to show these slides because this is the outcome of a BTech project student who worked with me for 6 months. In 6 months, he designed an antenna which is reconfigurable, and the reconfiguration is achieved by using a servo motor. And the servo motor is actually, controlled by an Arduino microcontroller. This is the overall setup, and this is an antenna which is smart, which is frequency reconfigurable, which is agile. And this antenna has an applications for cognitive radio applications. It appeared as a feature article in our IEEE Antennas and Propagation Journal. The title of the paper was An Antenna Advanced for Cognitive Radio. This is another kind of structure which is for wireless power transfer technology. So this particularly I want to show that UG engineers, if given proper impetus and proper directions, they can really do very good work. I was talking about the drone. As far as the drones are coming into picture and the different kind of small antennas are coming into picture, they have versatile applications starting from health monitoring to Internet of Things to wireless sensor network, in the wireless power transfer, powering the drone. I mean, nowadays, the government of India is having different kind of initiatives for surveillance, for different kind of applications, especially for medical emergency cases, especially for the the body organ donation. When someone donates a part of his body after his death, of course, then you have to ensure that the part reaches to the receiver in a very short time. So their drone is being considered as a big solution. So powering this drone is also very important. So new focus on the terahertz antennas, which requires nanoelectronics, photonics, antenna engineering, of course, and the material science. So these are really the multidisciplinary research. We need almost all kind of engineers to go ahead with this kind of work. And finally, this is the last or probably second last slide, the energy harvesting for biomedical applications or wireless power transfer. As I said, that electronics are being embedded inside our body for different kind of applications, starting from our hearing aid to the pacemakers and all. So sometimes even just to replace the battery, the person has to go for a second surgery. It's not needed. The new technologies are trying to work on a system where we can try to send the power wirelessly inside an embedded body. So this is another area of opportunity for the new electronics and the biomedical engineers. This type of experiment started long back. I mean, this is a slide from, experimental setup from MIT group 2007, first showed the wireless power transfer in a lab, but now technology has progressed a lot and we are thinking of powering, the biomedical gadgets and also the consumer electronics, the and the transport vehicles, which requires, of course, the high power level. So, and the new challenge is to powering these drones. One of our students of, group of students, along with some faculty mentors where I'm also involved, we are trying to do work some wireless power transfer using that antenna technology. So with this, I come to a conclusion of my talk, and I just wanted to tell you about a proven learning cycle. So this proven learning cycle, because ultimately, the motto of this particular workshop is to give you a new directions how you can take your career in a proper, with proper focus to get either a job or a higher education or think of some other out of the box things. So whatever you do, fundamental needs to be very, very clear and this. So there, that happens in the classroom. But if you just stuck to that on and just want to get good score, it wouldn't be enough. So you need to get involved with the course-based projects. When I say you need to involve, means it is, the faculty members also have to have those kind of initiatives. Then you can do different kind of mini projects during the semester break. I have seen from my experience with various generation of students, with me and with other senior faculty members, those who take good internship work in his institute or other institutes or industry, they excel. Definitely they excel. So you should take these opportunity. So final semester project is the key. And I always tell, if you have done some work, that work should be visible by other people. So you have to report the result. I definitely, everyone don't expect that a BTech student will be publishing in a journal, but a very good high quality conference paper, definitely it should come out, because that enriches your CV, and enrichment of your CV is very, very important, whether it be it a higher education or a job interview or anything. So attend the conferences, of course, with a meaning. When I say attend a conference with a meaning, means I mean you attend a conference for presenting a paper and interact with the delegates and the stalwarts who are coming in that conference. So innovative learning and teaching, high quality internship with the industry and other institute, different kind of opportunities government of India is having under DST. Currently, we have accelerated big gun scheme where the faculty members can, offer internship for different kind of students to his own institutes, and nearby institute students can write to them. So government of India is having new initiatives, that DST, imprint and the industry academia projects are being also conceived and being encouraged. And of course, the higher studies options are there, especially if you want to have higher studies, whether it is MTech or MS, especially if you want to land in some world-class reputed institutes, some publication at early career is very, very important. So this is the conventional thinking, but out-of-box thinking, of course, is there, and that's why there are new initiatives of Make in India and incubation. The government is promoting, different institutes are having their own scheme to encourage the incubation. And finally, whatever you do, whether you take a higher career or whether higher studies, or you go directly on a job, or you start your own startup, you are ultimately serving the nation. So with this, I concluded talk with this first in a couple of slides more. Don't solve irrelevant problem. Don't do which is irrelevant. So some people say, especially in our area, I have seen, say, robust technique I have developed to do something for which always there is a very simple solution available. So don't propose a sword which can, slice the bread, because slice bread requires just a small knife, not a very big weapon. Similarly, don't say, I have designed something which is crazy. My elephant can move in the backward. Fine, your pelican can move in the backward, but what is the application? So whatever we do and wherever do, the innovative thinking is very important. And then you can apply this experiment. I have tried it many times. There are some students, who are always very much bookish. So, if you apply this experiment to a kid who is just learning the unitary rule, you just ask, a 1 year cow has 4 legs. How many legs does a 2-year cow have? He will apply the unitary rule and he will say 8 legs. But then you see, a grown cow is not having 8 legs, it has 4 legs, because the unitary rule doesn't work always. So proper thinking, rational thinking, innovative thinking is very, very important to have a proper career in whatever fronts you think about. So, all of you that Three Idiots movie, that famous zero gravity pen by Professor. But the first venture, I mean, the first guy did not get the award. Ultimately, the out of box thinking, the Rancho, the Amir Khan, he got the award. So I request all of you to have innovative thinking. With this, I conclude my talk with tribute to the real heroes, not the real heroes, the soldiers, the doctors, the professors, the paramedical staff, the space scientists who are serving our nation. So thank you very much. I conclude my talk with information about two books that I have published and also with an information regarding an opportunity in my research group in terms of two positions on GRF and SRF and PhD position at my AST. Thank you very much. I try to shout at highest possible level, but it is raining very much here.
Thank you, sir. I think you have taken a lot of strain on your voice. There is a question from participant. Can you take that question?
Yes, definitely. Please.
He's asking about information about higher studies in astronomy or astrophysics.
Can you please repeat it?
Can you give some information about higher studies in astronomy or astrophysics?
Yes, good question. So, I assume that the question is from UG students. So, if you want to have a higher studies option in this particular astronomy or astrophysics, from Indian perspective, first let me tell. So, there are MS and PhD options which are through either GATE or through JRF Net. JRF Net is typically for science students. For BTech students, it is through the GATE exam. Of course, you have to have a GATE in ECE typically to get a position in this particular MTech or MS disciplines. In our institute, there is an integrated scheme also. Integrated means that BSc, MSc or BTech, MTech kind of scheme. And in India, TIFR has very good opportunities, Tata Institute of Fundamental Research. And GMRT Pune, they don't have higher studies opportunities in that sense, but you can approach them for do high quality internship in their particular area of astronomy, astrophysics, and etc. And coming back to the other opportunities which you may conceive is, of course, the MS, for which you have to have that GRE and other kind of thing and little bit of qualification. So this is the immediate response from me, but there might be more options because now other organizations and some private players also coming into picture. But as far as the national and international opportunities are there, so some of the opportunities with my institute, TIFR, and then as I said, GMRT Pune, some other IITs. And then when you think about the space and astronomy outside, you should target NASA, ESA, and some of the European countries, because European Space Agency and the NASA, America, these are the two major players in the space agencies. But of late, Australian National University, Singapore, etc., are also doing good.
Okay, thank you, sir. You have taken the session into more technical details about space engineering, the latest technology, and then to the job and research opportunities. I believe this will be really useful to the aspirants of avionics and space engineering. Thank you very much, sir.
Thank you. Thank you very much. Yeah.
Thank you.
Thank you, Chinmay. Thank you, Chinmay, very much. And as the time constraint is there, we will start with our.
Sure. Please go ahead.
Okay.
Thank you.
There
Thank
is
you
one
very
more
much.
question that we will mail to you. One more question in the chat box.
Please do that. Please do that. Yeah.
Okay.
Sure. Thank you.
Okay. With this, we will move on to the next session on architectural engineering by an eminent person, architect Sebastian Jose. So I welcome you, sir. I will introduce architect Sebastian Jose. He's a chief architect at Shilpi Architects Cochin, one of the leading architectural firms in the country, with an accomplished track record since its inception in 2000. Architect Sebastian completed his undergraduation from TKM College of Engineering, Kollam, 1995 as a batch topper. His passion for landscape design led him to the prestigious master's program at the School of Planning and Architecture, New Delhi, which he completed with distinction and third rank. Upon returning from Delhi in 1998, architect Sebastian joined the Kochi-based firm Design Combine and worked as junior architect before eventually embarking on his practice. Architect Sebastian has been an active member and has held key position in IIA, IIID, and ISOLA over the past 20 years. Architect Sebastian's passion and commitment towards architectural education have been consistent, and he was founder principal at Bishop Jerome School of Architecture, Kollam, before starting his journey as one of the trustees at APJ Abdul Kalam Charitable and Educational Trust. Architect Sebastian is also visiting faculty and a regular at many architecture schools across Kerala. At SEED, Architect Sebastian has been at the forefront of setting up an enthusiastic team of cutting-edge practitioners and academicians to deliver his dream of a school that nourishes critical thinking in the field of architecture and design. With these words, I welcome you, sir, to the session.
Thank you. Thank you, organizers, for those kind words. I really am thankful to all of you for finding me fit to be part of such an elite panel. This webinar is very relevant at this point because I am sure a lot of youngsters are looking forward to such events, which give them a better perspective about how to choose their career. So, as an architect, or having studied started architecture study in 1990, I have almost 30 years into architecture, and I would like to share some of my, the knowledge that I have gained over the years. Shall I share my presentation?
Sure.
Yes, sir. Sure.
So, this is how I have tried to structure my my seminar, starting with the meaning of architecture, how architecture has evolved over the ages, and what is the role of architects in society, what are the various fields of architecture, and ending up with some of the works that we have done and to put things in context, instead of talking what we have really been able to do. So what's the meaning of architecture? The term architecture is derived from Greek words, which roughly means chief builder. In India also, we have this concept of Vastu Shilpi, or the Stapati, which also essentially means the same thing. So all over the world, architect, this is one of the oldest of all professions, and it addresses one of the three main requirements of human beings. That's food, shelter, and clothing. So shelter being one of the most essential requirements of any human being. So architecture, what architects do, that it's a process, and the process of design is very important, and we have an end product. And so planning, designing, and constructing buildings or structures, where both the process and the plan and the product are very important. Architecture works in the material form of buildings are often perceived as cultural symbols or works of art. A unifying or coherent form of structure, it's an amalgamation of the knowledge of art, science, technology, and humanity. So basically, an architect is an all-rounder. He has to combine his creativity with the knowledge, with technological inputs, and also adding the human element. So the famous architect of modern era, Ludwig Mies van der Rohe, one of the four great masters of the modern architecture, he said, architecture is the will of an epoch translated into space. Roughly meaning you need to design for the present. Each architect tries to do what is relevant for the present. So just to put everyone in context, I have taken this. I'm starting with how architecture has evolved over the ages. One of the oldest civilizations that we ever know is the Mesopotamian civilization, and many people have heard about the ziggurats or the hanging gardens of Babylon. So again, we in Indus Valley had the Indus Valley civilization. The excavations at Harappa and Mohenjo-daro revealed great engineering and great town planning systems. They were highly developed in their drainage systems. Then roughly around the same period, you had the Great Pyramids and the Sphinx and the great Egyptian temples. The European architecture, the earliest European architecture was started by the Greeks. We have the famous Parthenon, the Acropolis, and the Doric, Ionic, and Corinthian columns are all still part of architects' vocabulary even to this date. Following the Greeks, the Romans built the great Colosseum, the Pantheon, and the great Roman Forum. After that, the Middle Ages in Europe, we had the great Gothic architecture, which was highlighted by its beautiful structural system, where the delicate structural system, the flying buttresses, and Notre Dame in Paris being a classic example of this Gothic cathedrals. Around the same period, in Central and South America, especially in Mexico, you had the Aztec and the Mayan civilizations. We have similar Mayan pyramids, very similar to the ziggurats or the Egyptian pyramids. After that, in Europe, you have high Renaissance styles, and the St. Peter's Basilica in Rome and the Duomo in Florence, designed by the great Michelangelo, are classic examples of Renaissance. Renaissance is basically an evolution on the classical traditions of Greece and Rome. Again, cathedrals in Milan and Rome. Then we have the Baroque architecture. It's a highly ornate and theatrical style, and it evolved from around Italy in the 17th century. Of course, in Asia, we had similar great architecture developing. The picture in the background is the Angkor Wat in Cambodia. It's a fine example of Asian architecture because it combined Indian and Southeast Asian architecture. Chinese architecture had a different origin related to its context and its culture and the materials available in that part of the world. So, and it influenced a lot of other countries, including Japan, where Japan actually came out with different kind of architecture, a bit more varied architecture, which was essentially using timber, but very well addressing Japan's problems like the earthquakes. And these classical masterpieces exist even today. Korean architecture also is developed in similar lines. We in India also had great architecture. We are proud of our architectural heritage. Nalanda University, one of the oldest institutions ever. We had great rock cut temples in Ajanta, Ellora, and Elephanta. We had the great Dravidian temples. We had the great Konark Sun Temple are all great Indian architecture marvels. And then we had the foreign influence. We had Islamic influence in the around the 10th century early, and then Qutub Minar being one of the early examples of Indo-Islamic architecture. After which we had the Mughal rule. They imported Persian influences into our architecture. So there was a combination of Indian architectural skills with the Persian traditions. And then we had some fine marvels of more great architecture evolving. And Taj Mahal being one of the finest examples of that era. And it is said that Taj Mahal is one of the most perfect buildings man has ever built. So we can be proud that we belong, it is part of our country. And then the British and the Europeans came and they brought European architecture traditions into India. So these European architects combined Indian architectural traditions, Indian techniques also into the European ideas. And then we have the Indo-Saracenic architecture, the great Victoria Terminus, the Victoria Memorial, and at a later stage, the Lutyens Delhi, the great Rajpath, the Rashtrapati Bhavan, and the North and South blocks are classic examples of the Indo-Saracenic architecture. So post-independence, we had the great Le Corbusier coming into India to design the Capitol complex in Chandigarh, and Louis Kahn designing the IIM. And so they influenced the the later generation of Indian architects, and which was followed by great Indian architects, the Pritzker Award winning B.V. Doshi, the great Charles Correa, Raj Rewal, Achyut Kanvinde, all great masters of Indian architecture, who actually have set the trend for the current Indian architecture architects. So we in Kerala are proud that we have Larry Baker, who inspired a generation of architects to look at architecture specific to our context. Right now, we live in a contemporary, modern world of architecture. So it's called a contemporary architecture. What the contemporary architecture is basically about rejection of ornamentalism. It's about being very bare, about a lot of open plan and a lot of use of glass. Some of the most prominent modern architects include F.L. Wright, Le Corbusier, I.M. Pai, the great pyramid, who built the great Louvre pyramid in Paris, and of course John Utzon's the Sydney Opera House stands not just for Sydney, but also tells you about Australia. So that is the kind of impact that an architect can have. That his work stands, Sydney is represented by his architecture work. So similar to that, Antonio Gaudi in Barcelona. The whole city is, is a big tourist destination, largely because of Antonio Gaudi's works there. So what is the purpose of architects in society? The responsibility of architects lie in part believing that architecture can create better spaces, making a place civilized by making a community more livable. So architects have a larger responsibility to create better spaces. And in our current times, we have a responsibility to have our designs more sustainable. And the idea of sustainable design is to eliminate or minimize the negative environmental effect of your building on the environment, and also to connect people with the natural environment. So what is architecture? Architecture is everything. It has to do with the structure, the materials, the purpose, the context, and function of a building. It's everything together, and you simply cannot separate these things. So it is a combination of everything. You need to visualize a great structure, but everything has to come together. So what is the foremost role of an architect is to create habitat. Is to create habitat for society or individuals. Creating places for working and living. So architect has to be an all-rounder. He has to work with various disciplines to visualize the final product and try to achieve that final end product. So it has to be building should be well constructed and should serve a multiplicity of functions. Promoting sustainable development through practical application of materials and showing sensitivity to the natural environment is the need of the hour. So architects should be wired to care. Actually, that social responsibility is very much part of should be very much part of an architect's thinking. Architects transform chaos into order by bringing dreams into realization. So you, as an architect, when you see a site, you think of the beautiful space that can, or a building that can come up in that space, and that visualization, that from a bare side, how to visualize such a beautiful space where people can be inspired, or people can, you know, find living and working spaces. That is the role of an architect. The architects have to respect the past, they need to perform in the present, and also make sure that their work is relevant for the future. And architects contribute to work of art and culture by providing identity to a place. Civilizations are now remembered or studied through their built form. The classic examples being the Eiffel Tower in Paris, which actually you see the Eiffel Tower and you say Paris. Similarly, you see the Sydney Opera House and you say Sydney. So that is the scope of architecture. So what is architecture as a profession? What is the responsibility of an architect? How does he go about doing his business? So basically, you need to have clients. Your clients bring you projects. So what do you do when a client reaches you? You research and analyze. You discuss with the client. You research and analyze his design brief, and as also the brief of what are the requirements of that project, what are the spatial requirements of that project, and then you come out with your you work out a design brief where the process is very important. You come out with your concept and you express your concept in terms of 2-dimensional or 3-dimensional drawings. And also you need to properly communicate your design to the client to make sure that he is in both of you are in the same page, and you communicate. In the idea of this communication, especially through drawings, is very important. So once you've sold the idea to the client, you need to be part of this large team which executes the project, and you take the lead role, and you specify the materials, textures, fixtures, everything to bring that final quality, final form. What are the career prospects of architects? So career architects can they can start their own firm, as also they can venture into sectors of construction, urban planning, urban development corporations, public works department, interior designs, landscape, etc. So basic eligibility to be criteria to be an architect is, of course, a 5-year BR course approved by the Council of Architecture. The Council of Architecture approved course is very important to be an architect. Some of the frequently asked questions on BR. So what's a Bachelor of Architecture course? The Bachelor of Architecture program is a full-time course structured to allow students to understand human habitation by exposure to different contexts. So basically, the difference, the fundamental difference between probably an architecture course and a civil engineering course, and many people confuse this, because in architecture, more than 50% of the time is spent on developing your design skills, and almost more than 50% of the time is spent on that. So that is where over 5 years of study, you kind of develop your design skills, and inculcate in the student the idea, the process of going about a design. So that is where, in addition to studying the basics of civil engineering, he needs to study electrical engineering, bit of electrical engineering, mechanical engineering, which are all concerned with buildings. And also he needs to study sociology, psychology, basically to deal with how to deal with people and clients. And of course, he needs to be a good financial manager also, and bit of economics. So he has to have a all-round knowledge about everything to be a good, successful architect. So why study a 5-year program? So this is what I was saying. So you need to, for getting so much of information into your head, you need minimum 5 years, and COA stipulates a 5-year course. Some people ask whether BR can be done part-time or distance learning. No, so far COA, Council of Architecture, doesn't allow that. And what is NATA? NATA is the National Aptitude Test for Architects. It is the common entrance test for all over India for selection into architecture courses and selection in the council-approved architecture courses. The national education policy, of course, has a lot of relevance. Architecture education also is going to change. Instead of the 5-year undergraduate program, and then further 2 years of post-graduation, which I have done, I think in future students are going to end up doing a 3 or 4 year undergraduate program, where they can move out, have a basic degree, but then you can also study the straight 5 years with an integrated PG, and then probably at a later stage take up a test prescribed by the Council of Architecture to start doing for getting your registration. So this NEP will be flexible in terms of your curriculum structures. It's a choice-based curriculum. You will have multiple entry and exit points to your course. So essentially, architects, students studying architecture can move out after 3 or 4 years into probably similar streams, maybe into design or interior design or product design or other streams of design as well. So that will be a basic foundation course. But to start really practicing architecture, you will have to to earn a license. You will probably have to work, study the whole 5 years. Some of the notable architecture schools in India. In the north, we have the School of Planning and Architecture, one of the finest institutions, which it's a coveted institution for a lot of aspiring architecture students. In the West Zone, you have the CEPT University, again, a great institution, great infrastructure, a great place to learn architecture, and the place is very inspiring. The designed by architect B.V. Doshi, it's a fine campus and a very, very good place to study. JJ School of Architecture is one of the oldest architecture school, has great traditions. In the south, we have the School of Planning and Architecture and Planning in Chennai. You have the NIT Trichy, and of course our own College of Engineering Trivandrum is the oldest architecture school in Kerala. In addition to this, there are a lot of good private architecture schools all over India and even in Kerala, which offer very good architecture course. So some of the questions usually asked about architecture practice is people ask whether it's worth being an architect. Yeah, it's a creative, very diverse and ever-changing subject and profession, and provides huge array of opportunities. And here I would, my professor in School of Architecture, Delhi, he once told us that you architects should consider yourself lucky, because you are one of the you are into a very rare profession where what essentially you end up doing is expressing your creativity, is something which you dream, and then there are people out there who are willing to spend the money and make sure that your dream comes into a reality. There are very few professions where you are, and at the end of the day, you are again paid your fees. So you're basically having a good time, and there are people out there to support you. So Professor Shahir, so this word Professor Shahir has been at the back of my mind ever since. So I consider myself to have landed up in this beautiful profession. And what are the skills that you need as an architect? So you need design skills, of course, a lot of knowledge about all-round knowledge about construction. You need to be very well versed in construction techniques, and you need to have meticulously detailed thinking. You need to go into the details to bring the finer details of buildings. Many people end up doing great designs, but when it comes to the execution, some of the buildings flop in the details. So, and of course, thinking and reasoning skills, customer service skills, That's very important. You may come out with a great design, but you are not able to sell the product to the client. Then you are a failure. So you need to communicate well with the client. Of course, you need to be good in mathematics, and above all, quite resourceful. Can BR course be done part-time? That's again a repetition. No, council doesn't allow you to do that. Many people have asked if the course of architecture is really hard. I should say no. If you really have the aptitude for the course, I landed up in architecture. Not sure whether it was the right, because 30 years back there was, I'd hardly met an architect, but I got into architecture only because my father was building his house, and I got interested in the construction part of the building. So I took up architecture. But then after 1 month into architecture, I realized that this is my course, and I started enjoying. I had to do a lot of hard work, of course, but what you do with passion, and what if you really love what you doing, then there is you will it's not a big hard thing to take up. So architecture is, of course, a lot of hard work and a lot of dedication, and as an architect you need to keep yourself updated every day. So this learning process in architecture doesn't stop in the 5 years. So I have post the 5 years, I have now 25 years into my profession, and I'm still learning each day, looking at the small things. Every single moment is a learning process for an architect. So some people ask whether is it rewarding as an architect in a practice. Of course, ultimately most people would love to end up starting their own office, but nowadays there are big offices, and it's about teamwork. So you always can be part of a big team where you need not always have the entrepreneur skills to make a fine architect. You can always be part of a team. As architects, you travel a lot. You may have sites all of any part of the world. So there is an opportunity to travel, and also nowadays architects try to travel a lot, because to expose yourself to a lot of new ideas and new techniques and new developments. And so the traveling is a very important part of an architect's job. What are the various fields of architecture? How people can after the graduate program, what are the courses that people can take up? They can move into landscape architecture. I studied landscape architecture at the School of Planning and Architecture. Landscape architecture is basically concerned with the design of the outdoor spaces. So it makes you look at buildings at a larger level, taking into account the landscapes or the environment into consideration, and making fine outdoor spaces is the final finally what a landscape architects do. Of course, interior design, the people who have taste for fine taste, who think in details, they take up interior design to enliven spaces. Interior designs is a great field. You move into you work on the fine details of materials, textures, etc. in interior design. Sustainable architecture is an evolving field, and it's very much the need of the hour, because sustainability is very important, especially for the survival of humanity. So how to minimize your environment and impact on your buildings, of your buildings on the environment, it's very crucial. So they systematically analyze the environment and impact of your buildings and come out with solutions. So sustainable architecture is coming up in a big way, and is very relevant. Urban design makes you look at buildings at a larger level, not just the building alone, the whole public architecture, design of streets and spaces. So urban design think at a level. it is about preserving your heritage, how to the technical aspects, and also how to preserve your built environment, built heritage, and how to preserve it for the future, and also find useful, meaningful use in the present times. Some of the works that we at Shilpi Architects, to put you in context, we always, as architects, we learn and then we try to assimilate these thoughts, all the body of knowledge, and try to, bring it out in some form or the other when you get a project. So some of the projects where we have tried to push the envelope. This is a chapel for a congregation in Kochi. We are trying to use, come out with a slightly different vocabulary on church architecture, make it the structure, basically the idea is to have the form following the function, expressing the materials,
So Sebastian, you are not audible.
Sir, I think you lost the voice.
Pardon?
I think his voice is lost.
Yeah.
I think it is totally stuck. It has to.
Seems so.
Mm.
Maybe connectivity problem there.
Mostly, it looks like so.
Kasim sir, shall we wait or?
Yes, please wait. Let me contact Sebastian, sir. Let me contact Sebastian, sir.
Okay.
എന്താ വിട്ടുപോയി, മറ്റേ സ്ക്രീൻ മൂവ് ചെയ്യുന്നില്ല, ശബ്ദം കേൾക്കുന്നില്ല. സാർ ആ സലഫി മസ്ജിദിന്റെ സ്ക്രീനിൽ നിൽക്കുകയാണ്. ഓക്കെ.
I'm really sorry. I think I got disconnected somehow and I didn't realize. I think I'll start with where I left. I think at the masjid.
Yeah, exactly.
Yeah. I'm not able to share because I think I'm not the host anymore. If you can make me the host again.
Madhu.
Madhu Krishnan, or
yes, sir, I'm still on it.
Balu. Okay.
Balu, please.
Yes, got it.
I think
Yes,
you
sir,
can
please
share.
continue.
Can share.
Sebastian, sir.
Sir, can you share the screen now? I think still there is some connectivity issue, Kasim sir.
Yeah, let us wait. Sebastian sir, can you hear? Can you hear us?
I think he lost.
I think we are running short of time actually. So probably we can move to the next session. Yeah.
Just wait. Let me check. Sorry.
This audio is also looking missing. No device.
പിന്നെയും പോയാ അപ്പൊ മറ്റേ സാറിന് സംസാരിച്ചിട്ട് വൈൻഡപ്പ് ചെയ്യാമോ? സ്ലൈഡ് വേണമെന്നില്ല, അങ്ങനെ ചെയ്യൂ. ഓക്കെ താങ്ക് യു. സാറിന് സെബാസ്റ്റ്യൻ സാറിന് ഒന്നും കൂടെ ആഡ് ചെയ്തേ. പ്ലീസ് ആഡ് സെബാസ്റ്റ്യൻ സർ. സെബാസ്റ്റ്യൻ സാറിന് ഒന്ന് ആഡ് ചെയ്യൂ. ഹൈ രാജേഷ് സാർ.
ഹായ്. ഞങ്ങൾ പ്രീ ഡിഗ്രിക്ക് ഒരുമിച്ച് പഠിച്ചതാ തൊടുപുഴ ന്യൂമാൻസ് കോളേജിൽ. നാളായി കണ്ടിട്ട്.
Sorry.
Yeah, please sir.
Yeah. Sorry, I think some network issue here. I'm getting lost in between. Yeah, can you make me the host again? Yeah, thank you. I'll just quickly wrap up. So this is at the Salafi Masjid. So I was trying to work out a new vocabulary, my own vocabulary, my own slight take on the mosque. Try to, again, but retaining the basic idea. People should feel that it's a mosque, but trying to use natural light. Also use jalis to come out with a slightly different vocabulary. Again, it's a house that I designed. It's a house that I designed in a lakeside. How to respond to that landscape? It's a rolling hill, but to retain the landscape and bring a lot of greenery into the building. And that picture at the right-hand top corner is basically the idea of the house, to connect you to the landscape and make you feel part of the landscape. This was a highly rewarding project. It's the house designed in just 3 cents of land, and where we used a lot of natural light and spatial to reduce that tight space, feel of tight space. We devised some interesting techniques. Anyway, it has a project. Again, another house in a different context. It's a house on a backwater on the Vembanad Lake. Again, very simple contemporary take on architecture, and this is very open plan, very open to the landscape, and basically to connect you to the landscape. There's a commercial building that we did on the NH bypass in Kochi. Again, to respond to a junction, this lure system was devised by us, and now this lure system has been taken up by this company called Fundamax, and they are patenting this lure system. So we are happy that we could be part of such a thing, and we are able to devise this lure system, basically to address to reduce the thermal load on this building, and also come out with a landmark, make that building a landmark. This is a convention center that we designed. Again, very frugal on materials. Again, form following the function. Large convention center, but use of minimum materials and minimum, and a lot of used a lot of curves, but they were all designed with a reason. Very simple building. There's an apartment that we designed in Kochi called Water Lily. The idea is to connect you to the landscape and make you part of the water body. So again, the same ideas, but how to connect you to the nature. That was the key. Okay, that's about it. Thank you, organizers. Once again, thank you all for listening to me patiently. Do we have a round of questions?
Thank you, sir. I think we don't have questions. So actually, thank you, sir, for taking us to the beauty of architecture engineering, and by emphasizing the role of architect in the society, and also giving us on your own designs, showing us your own architectural designs. Thank you very much, sir.
Thank you. Thank you.
Yeah, thank you, Sebastian, sir.
Thank you, sir. Thank you.
Sebastian,
I'm glad that
good
I could
evening.
be.
Thank you.
Rajesh.
Rajesh.
Rajesh. Okay.
Classmate. +2. PDC.
Yeah.
Yeah, thank you.
Okay. Now I hand over the platform to Kumarivel, sir, to introduce the next 2 sessions and the participants.
Yeah, thank you. Thank you, Hindo.
Thank you.
So thank you very much, sir. We have limited time hereafter because already we reached 6:10, 6:07. So good evening to all of you. We have 2 more speakers today. The immediate speaker is engineer Hanif Shijaz, who is currently doing PhD in DUT and EUT Netherlands. And we have 1 more speaker, engineer Radhakrishnan A. So I would like to introduce the immediate speaker, engineer Hanif Shijaz, who is currently pursuing PhD at Delft University of Technology, Netherlands. So he completed his MTech in computer aided process and equipment design at NIT Warangal. He done his BTech in chemical engineering at a GEC Calicut. So with this brief introduction, I invite engineer Hanif to speak about chemical engineering stream. Welcome you, sir.
Thank you, sir, for the introduction. I'll try to share the screen now. So can you hear me well?
Yes, sir, we can.
Okay. So actually I'm joining from my home quarantine. I came to Kerala, so I'm almost finishing my 2 weeks quarantine. So I connected to the mobile data, so I'm not sure like the connectivity, how that would be. So that's why I turn off the video. So I think you can see the screen now. Yeah. So I'll try to mix both languages, Malayalam and English. So I think also the parents of some school students might have joined. So let's try to get across this message to most of the participants. So I think there are no objections in that. So first of all, thank you very much. A special thanks to Professor Samisa to invite me as a speaker to this event, along with other eminent professors, associate professors, assistant professors, directors, advisors, CEOs. So it was very inspiring moment to see myself in that poster. So hope that fuels me to give more presentations in the future. So that's something I'd like to do. And coming to the event, what I'm trying to do, try to address, of course, the opportunities and challenges for engineering educations, especially chemical engineering. So in my opinion, the event is a challenging task because when I look for the audience, there are school students and also the undergraduate and postgraduate students. So they are multi-level audience. So it's very challenging to satisfy all the audience in 20 minutes. But my objective is like, I think the undergraduate students, they're already in the pressure cooker, so they will find a way out from the pressure cooker. But the postgraduate students, they are in a rice cooker now because they found their interest. So they are special breed of people, they will also find their way out. But I take the full responsibility to give the guidelines or the precautions or tips for the preparations for the people who are going to enter that pressure cooker. So those are the school students. So let's try our best for 20 minutes. So chemical engineering in the chemical engineering and the job opportunities and then chemical engineering. So that's what I'm going to say in this presentation. So for the school students, let me go back to my high secondary school. In 2008, when I finished my high secondary school, I was not a student who was interested either in engineering or medicine. So I always wanted to be a teacher. Still, I want to be a teacher. So as I achieve teachers in the high secondary school teachers, and so I know they did their BSc, MSc, and BEd. So that's how I designed my future for. So I'll do the BSc, MSc, and BEd. So I was a chemistry-loving student. So that was my route. But like all other students, engineering and medicine exam, entrance exam already. So I qualified for engineering exams. Then someone told me, okay, you can also be a teacher and an engineer too. So I thought, okay, it's a good choice. Then I looked into the prospectus for the first time after then. Then I found this chemical engineering because it sounds like something related to chemistry. So back then, there were a lot of resources and so even internet, you have to pay 20 rupees, go to a cafe, then you see the circle, it's always circling. So that was the time, even in 2008, so you can imagine. So my main resource, I used to ask the teachers, my teachers. So I asked my school teachers and the tuition teachers, what is it, chemical engineering? So one of them told me, it's full of chemistry. So that was my chemistry teacher. So I was so happy, okay, I'm going to pursue chemistry in engineering. And another teacher told me, if you want to travel around the world and make a lot of money, go for it, okay? So, but that was not my thing because you can do it with any other profession. So I didn't get a complete idea what exactly chemical engineering is. So still the question remains, what exactly is chemical engineering? So as a student from a school, then I was so curious, like what are the subjects I'm going to study in this? And what are the jobs? Do we get a job or not? So I think even now the students have the same questions. So throughout the presentation, I'll try to address. And also there'll be some nice tips for the undergraduate and postgraduate students as well. So the first thing, what is chemical engineering? So I say this is one of the latest engineering disciplines. So last 2 days, you're following this course about when did this course have started? Mechanical engineering in the electrical engineering, they were there from the beginning. But chemical engineering is one of the latest discipline. It actually emerged by the late 19th or early 20th century. So the main reason for chemical engineering was industrial revolution. So what happened with the industrial revolution? So if you know, like these are the two oil bottles. So can you see the difference in these two? I'm not sure like whether the participants are allowed to respond to my questions or they are muted by the organizers. I think they're muted, okay. So the difference you can see, the bio oil, and bio oil means that it doesn't have any synthetic materials. It's pure natural oil. So when you go to the supermarket, we are ready to pay extra than the 35 rupees or 50 rupees pay ready, because we are very cautious about the health issues. We are very cautious about the benefits from the bio oils. So that happened after the first industrial revolution. People were starting thinking about quality of the product than just quantity. Because back then, everything was produced in bulk quantity. Now I was worrying about the quality of the product. So that comes to the chemical industries. Chemical industry and the main production handle in the mechanical engineers, and because they design the equipments for the chemical productions. So, and the chemists do the experiments in the lab, the chemistry lab, chemistry experiments, and mechanical engineers industry producing. So people approach the chemist first, then they ask him, "Oh, can you do it? Like, can you maintain the quality when you produce things in bulk? With the word produces can you maintain the quality of the product?" He said, "No, I can do it in the lab, but when I go to the industrial scale, I'm a bit afraid of it." Chemist. So then they approach the second person, that's a mechanical engineer. And he told us, "I'm handling all these things, and another lab, but I don't know what's the chemistry behind it, so I cannot tune the chemistry to get the quality of the product." So what happened? They combined these two in a new branch called chemical engineering. So what chemical engineers basically do, they involve in the large scale production of chemicals and energy. But every engineers, all engineers, they should make profit. So how chemical engineers make profit? So they convert the raw materials to product. So how they make profit? Because the raw materials are cheap and they convert it into a value added, we call it value added or more expensive products. So they spend on raw materials and the process, they get some products. So that's how they make the profit. And how they make the profits? Oh, what are the products? So it's in your life, like when you wake up, bed clothes and the materials, when you brush and the toothpaste, brush and the materials, mobile phone, mobile phones materials, energy, breakfast, food, fertilizers, supermarket food products, your clothes, and if you go out with the car, the material and the fuel you fill in, and the things you purchase from your supermarkets, the carry bags you bring in. So everything from you wake up until you go to bed back. So you actually surrounded by the materials that's produced by the chemical engineers. So I'm not saying like it's only chemical engineers. Everyone is working together, but chemical engineers are really responsible for the industrial production of chemicals and these materials. So altogether, I like to put it in two baskets. One is material and energy. That's material and energy. So the material and energy last scale produce chemical engineer, right? Main duty. So these are some of these familiar companies for you that actually do this. So I'm not going to explain this because you know them. Then how do these chemical engineers do this? How do they produce things in large scale? So as we said, like it's from raw materials to products, but how do they do it? So the basic thing, it's a chemical reactions. So you have the raw material A and you get the product B. So there's a chemical reaction. That was a missing link before the Industrial Revolution. So now people are there who knows the chemistry. So there's a chemistry happens. And all of us know when you try to convert A to B, you cannot convert all A to B and you don't get only B. So they left some A and also you get some new products. So what do you have to do then? Because your customer needs only B. So you have to separate this A and I'm going to separate here. You can recycle, it's a different thing. And also you have to separate the waste product from the main product. So there is a separation process involved. And we call it post-treatment because this is a main step. This comes after that. But there should be pre-treatment as well because you get some raw materials. You cannot pour it into the vessel as such. You have to do some pre-treatment, something like you have to wash it, you have to grill it, grind it. So it's mostly mechanical operations. So we call it pre-treatment process. So this is how chemical engineers work on that. So I'll come to this point later. So the main thing, maybe for school students also, for the undergraduate student, when they study the subjects, they must know like why I'm studying this, just to pass the exam. You have to do a lot with that later. So the first thing, as I said, the core part and the main part of the chemical reactions are. So there are two courses in chemical engineering. The first one you can see, this is basic chemistry. So you have to practice some calculations using chemistry. So that's a foundation course in chemical engineering. So every engineering discipline has a foundation course when you join. In the first year, I think now you probably provided an entire overview of the course. They given information about all the courses you study from the first year to the last year, because I was involved in it when I was teaching in TKM College of Engineering for 1 year. So that's a good thing. And the second one is a chemical reaction engineering. That's a main engineering the chemistry. That's the thing. So these are the main 2 subjects. So that comes here in the central part. And when you go to the post-treatment steps, as I said, we have to separate something out of the main products. So there are some, we call it transport processes. The 3 things we transport are mass. So there's mass transfer operations and heat. There's heat transfer operation and fluid mechanics. So you find very similar to mechanical engineering, because you know they were doing it well before. So now there's a sandwich of mechanical engineering and chemistry. So we have to, this is one of the main or unique subject for chemical engineers, mass transfer operations. So what is happening in mass transfer operation? We have to separate one component out of another thing. So what basically happens, so this is mainly for school students maybe, you have a mixture of A and B, you have to separate them into 2 different streams. So what you do, you add a separating agent that give you an intermediate phase with A rich and B rich phase, and there are some physical means to separate it into A and B. For example, if there is a difference in boiling point, so you apply heat, so one of them goes to the vapor phase and the other one remains in the liquid phase. Then you can separate the liquid and vapor. So that's a basic principle of it. And to understand it much better, that's a process of making tea. Because when you make tea, you must know how much tea powder has to be put in it. Tea powder color. So that's a mass transfer in it. The temperature, gas, that's a heat transfer in it. Then sometimes we stir it to make it a bit faster, and the mass transfer is easier. So it also depends on the fluid flow. So this is actually these 3 transfer processes. So that's also the unique subjects for something chemical engineers have to be expert in it. And then if you come to the first part, the physical treatment, there is actually the mechanical operations where we make the raw materials ready for the reaction. So that's actually the drying process, grinding. So all those things I'm not going to explain it now. Then some other interesting subjects. We have chemical process control, because when you have a plant, you have to control the conditions in the plant. So it's also related to other engineering programs like electronics, electrical engineering, and so on. So this is chemical process control the process for the chemical production. And chemical process design, that's of course the best part. Now we listen to Sebastian Sasso, he was talking about the design. So design is the best part of a process, because you have to think it well before, okay, what are you going to produce and how are you going to produce? So that should be the best way. So that's chemical process design. And of course, as I said, the engineer should make profit. So there's process economics part. So you have to calculate, I'm going to make profit with these chemical reactions and separations or not. And finally, safety first, because you'll be working in a chemical industry, or you'll be designing a large scale production where there's a high chance of hazards or something wrong would go wrong. So you must really think about your safety thing. So these are actually the main subjects or the core subjects. There are many more subjects. So that's why I said like you will enter into the pressure cooker. There are many more subjects. But still, my point is when you look at this, so these are the core subjects. So I told you, one of my chemistry teachers told me it's full of chemistry, and most of the people or the non-chemical engineers believe in it. Or even the chemical engineers who, when they enter into chemistry like me, I believe, okay, it's full of chemistry. But when I look at the subject and try to correlate that to my high secondary school subjects, there are only 2 subjects among the core subjects are chemistry based, and the rest of the subjects are mainly based on physics and mathematics. So like any other engineering program for chemical engineering, physics and mathematics are the backbone, but chemistry is our heart. So you need these 2 to stand up and keep going. So that's what actually chemical engineering. So don't ever think it's full of chemistry. I'm very good in chemistry, so I'm going to do it. But even if you're not good in chemistry or physics, you can learn any other engineering. That's a different thing, but still it's not fully chemistry. It's like any other engineering program. You learn you need physics and mathematics, most of your process or most of your activities in engineering. but the core part or the central part is the chemistry. You're engineering the chemistry and chemical engineering for the large scale production of chemicals. Then jobs. So that's the most important question. So here you can see what we are trying to do. We are trying to convert an idea into a real plant, a real production plant. So how we do it as a chemical engineer. So it's a diagram which shows, I'll explain it. So first of all, you get an idea. Okay, you think, okay, I'm going to produce this product. So first of all, you have to prove it in the lab, like the chemist. Go with your beaker, conical flask, everything. So do some titrations. Then you find, okay, I can produce this product. So once you get it, then you need a dreamer who really dreams high, because you have to produce this product in really large scale. ഈ പ്രൊഡക്റ്റിനെ ലാർജ് സ്കെയിലിലേക്ക് നമുക്ക് ആ ഒരു ഐഡിയ ലാർജ് സ്കെയിലിലേക്ക് കൊണ്ടുപോകണം. സോ വാട്ട് ദ ഡ്രീമർ ഓർ ദ കൺസെപ്ച്വൽ ഡിസൈൻ എഞ്ചിനീയർ ഡസ്, ഇതിനെ എങ്ങനെയൊക്കെ കൊണ്ടുപോകാൻ പറ്റും, നമുക്ക് പല രീതിയിൽ അതിനെ പ്രൊഡ്യൂസ് ചെയ്യാൻ പറ്റും. സോ ഹി ഹാസ് ടു കം അപ്പ് വിത്ത് ഓൾ ഡിഫറെന്റ് ഓപ്ഷൻസ് ഓഫ് പ്രൊഡ്യൂസിങ് ദിസ് പ്രോഡക്റ്റ് ഫ്രം ദ റോ മെറ്റീരിയൽസ്. സോ ദാറ്റ് വാട്ട് happens with the conceptual design engineer. Then he should propose a single process. ഇതാണ് ബെസ്റ്റ് പ്രോസസ് എന്ന് അദ്ദേഹം പറയാം. So once you get the best process identify the കഴിഞ്ഞാൽ we go for the detail engineering. We will size the equipment. We say, okay, നീ ഇത്ര വലിപ്പത്തിലുള്ള equipment വേണം, ഇന്ന raw materials വേണം, ഇന്ന equipments വേണം. So we do the detail engineering. So everything is set to construct your plant. And there comes the construction. Then we construct the plant in a construct ചെയ്യുന്നു, പിന്നെ സ്റ്റാർട്ട് ചെയ്യുന്നു. ഒരു വണ്ടി ഓടിക്കുന്നു, നിങ്ങൾ വണ്ടി ഓടിച്ചു, സ്റ്റാർട്ട് ചെയ്ത് നോക്കണം, സ്റ്റാർട്ട് ചെയ്ത് എന്നിട്ട് ഓടിച്ചു പോകണം. സോ ഇറ്റ്സ് an operation of the product units. Finally, കുറച്ച് കാലം കഴിയുമ്പോൾ വണ്ടിയുടെ പരിപാടി തീരും. സോ ഡീകമ്മീഷനിങ് ആണ്. സോ ഇറ്റ്സ് the same process. So let's see what are the job opportunities. For first of all, as a research and development section, you have to come up with an idea in the lab. So you can work in the lab as a research engineer. Mostly people with PhD, they work in this field. And then the conceptual designer who comes up with different options to produce the same product. So who are the process engineers? I personally work in this part to create ideas, different options, then to identify which one is the best economically, ഏതാണ് നമുക്ക് ലാഭം തരുന്നത്, ഏതാണ് എൻവയോൺമെന്റിനെ അഫക്ട് ചെയ്യാത്ത പ്രോസസ്. So you have to consider all these things. So that's what I see. You'll have different options and you have to find the best one. Then the design engineer, they do the detailed design. They take that idea, then they do the detailed design of the sizing of equipments and everything, what are the utilities required, and a complete design എന്തൊക്കെ പ്ലാന്റ് ചെയ്യാൻ എന്തൊക്കെ ആവശ്യമുണ്ടെന്ന് he does this design. Then finally, I call it field engineer. There are many things you might have heard about, like EPC companies എന്ന് കേട്ടിട്ടുണ്ടാവും, മെഷീൻ എറക്ഷൻ, പ്രൊക്യൂർമെന്റ് ആൻഡ് കൺസ്ട്രക്ഷൻ. ഒരു പ്ലാന്റ് കൺസ്ട്രക്ട് ചെയ്യുന്ന EPC കമ്പനി, ഫ്ലോർ പോലെയുള്ള കമ്പനീസ്. അപ്പോൾ അവിടെ ഉള്ളവർക്ക് EPC വിഭാഗത്തിൽ വർക്ക് ചെയ്യാം. ദെൻ സ്റ്റാർട്ടപ്പ് എക്സ്പേർട്സ് ഉണ്ട്, അതുപോലെ പ്ലാന്റിൽ നമ്മുടെ പ്രോസസ് മോണിറ്റർ engineers ഉണ്ട്. So they all come in the field engineers. You can work in the field in a plant to run the process. അതിനെ പ്രൊഡക്ഷൻ കൺട്രോൾ ചെയ്യുന്ന, നിങ്ങൾക്ക് ഡ്രൈവിംഗ് ഒരുപാട് ഇഷ്ടമുള്ളവർക്ക് ഇവിടേക്ക് വന്നു, ബിക്കോസ് യു ആർ ഡ്രൈവിംഗ് എ കെമിക്കൽ പ്രൊഡക്ഷൻ. ഒരുപാട് ചിന്തിക്കാൻ ഇഷ്ടമുള്ളവർക്ക് പ്രോസസ് എഞ്ചിനീയർ ആകാം, ഒരുപാട് പുതിയ കാര്യങ്ങൾ കണ്ടുപിടിക്കാനുള്ളവർക്ക് റിസർച്ച് എഞ്ചിനീയർ ആകാം. So it depends on your taste. And of course there is a new thing, or that's of course like your sales engineer. When you get a product, you have to convince your customers, okay, this is the best product that you get from than you get from the other clients. So it's actually a competition. You find a lot of chemical industries, everyone produce maybe same name chemicals but different qualities, so everyone has their own secret. So you should sell your products. That's all. So what is samsaric and communication skill, they can be the sales engineer after you graduate from chemical engineering. And nowadays there are many new field, how many new positions are also for chemical engineers. That's like process consultant. It actually happens here when you develop a technology, you actually go to the companies. നിങ്ങൾ പ്രൊഡക്റ്റ് സെല് ചെയ്യുന്നതിന് പകരം നിങ്ങളെ ടെക്നോളജി സെല് ചെയ്യാൻ വേണ്ടിയിട്ട് പ്രോസസ് കൺസൾട്ടന്റ്, ദെൻ പ്രൊഡക്റ്റിനെ കുറിച്ച് പഠിക്കാനായിട്ട് മോഡലിംഗ് എഞ്ചിനീയേഴ്സ്, സിമുലേഷൻ എഞ്ചിനീയേഴ്സ്. We heard about this in വർഗീസാറിന്റെ ടോക്കിൽ നമ്മൾ കേട്ടു. ഒരുപാട് കമ്പ്യൂട്ടർ സയൻസിന്റെ കാര്യം, ഡേറ്റ ഡ്രിവൺ റിസർച്ച് നടക്കുന്നു. സോ ഡേറ്റ എഞ്ചിനീയർ. സോ ഇനിയും ഒരുപാട് ഫീൽഡുകളുണ്ട്, ബട്ട് ദീസ് ആർ ദ മെയിൻ തിങ്സ്. And of course, you can be a teacher in chemical engineering. So altogether, you can either be a skilled chemical engineer or you can produce a lot of skilled chemical engineers. So this is also the best profession. And coming to the higher education, so you heard a lot about this in the previous previous talk, so I'm not going to explain more about it. So basically you do your bachelor's, master's, and go to PhD, and there's something maybe new for you, PDM. So what happens in bachelor's? Okay, most of the people do the same thing. Some of them, they made themselves into master course, and only a few of them they made to PhD. So yesterday, Verghese was saying about like you should do higher education, or you should prefer higher education during this pandemic. That's right. And also, even if it's not pandemic, you should really prefer your higher education, because you see there are not many people are doing it. So there will be a high market for you when you finish your studies. But a lot of the concerns when they finish their bachelor's or master's, life is start. So can I do both? Like, can I do higher education and can I have my life? So that's something I'm going to address. So that's basically you hear about these two, PhD, but there is something called PDN, Professional Doctorate in Engineering. So the Netherlands universities a program on TU Delft, Technical University Delft, and Technical University Eindhoven, and University of Twente. ഈ മൂന്ന് യൂണിവേഴ്സിറ്റീസിൽ പോസ്റ്റ് മാസ്റ്റർ പ്രോഗ്രാം PDN എന്ന് പറഞ്ഞ പ്രൊഫഷണൽ ഡോക്ടറേറ്റ് ഇൻ എഞ്ചിനീയറിംഗ്. നിങ്ങൾ ആരെങ്കിലും MTech ചെയ്യുന്നുണ്ടെങ്കിൽ, MTech ചെയ്യാൻ ആഗ്രഹിക്കുന്നുണ്ടെങ്കിൽ, even school students, if you aim for higher educations and if you're a good designer, you can really aim for this. So I'll explain more about it. So do you like to design? Then it's for you. That's a simple thing. So it's a 2-year salaried program. So, and why I mentioned salaried program, when I finished my master's, I had a lot of thoughts like, because I wanted to be a teacher, I know I should do PhD, but there was also an option to get into teaching position with MTech, because I'm the state government college, MTech join master. Even then you have to do your PhD, let us say, that's a different thing. So I was trying for that because I wanted to be the man of the family, everything. Everyone gets these thoughts when you finish your studies. So if you go abroad, you have to spend a lot of money. You should be really financially sound. So I didn't know about anything about that, like the financial requirements for PhD or other programs. So when all the doors were closed, I started checking about the programs abroad. Then I see, okay, you don't have to pay even a single rupee to go there, and you get educated. And also, you're not a student anymore because it's a salaried program. You'll be an employee of the university. And to give you more idea, like it's a 2 years program. 1 year you spend in the university, 1 year in a high-tech industry in other. And there are 2 intakes per year, average like 20 to 30 trainees per course. So it's very competitive, but if you wish, you can get it. And this is a salary. I've just given an idea about how the salary is. So the salary for this PDN program is around somewhere between 1,700 and 1,900 euros per month. It's a gross salary. So you get like 1,700 euros in hand, so you can do the conversion. And for PhD, you get more, like it varies every year because it's a 4 years program. It starts from 2,300 up to 3,300. So again, I repeat, you don't have to pay even a single rupee. Even your travel expense for the first time will be taken by the university. So you're going for free. So you'll be paid and you'll be an employee. You can have your family. You can be the man of family. You can be the woman of family. So if you wish to do, just do it. So the next question will be like, what do you need to get? Just the motivation. So if you're really motivated to be honest and write your motivation letter in that way. If you find a gap in that, just try to fill in that gap. You can do it, because I got this position with all the experiences here in India, because I did my bachelor's and master's in India. Then I worked as a guest lecturer in TKM, then NIT Calicut. So I didn't have any foreign experience, but I try to fill in the gaps of the motivation. I try to narrate my story in a way they like it. So you just need a motivation for that. And it's a extra tip for you. When you write a motivation letter, don't write an essay. Just write 1 page, because no one has time to read everything of yours. So if you write 1 page, they will definitely read it. Some of the points will strike their mind. And the CV 2 pages. That's just for you. And here I'm going to show you the chemical engineering PDN courses. In the chemical engineering PDN courses, you have courses in TU Delft and TU Eindhoven and University of India, in all 3 universities. Maybe the shocking factor again, because most of the PDN courses are for chemical engineers. So that really shows the need of designing a new process in producing chemicals and energy, because it has a huge impact on the large scale. പറഞ്ഞ നിങ്ങൾ രാവിലെ എഴുന്നേൽക്കുന്നത് മുതൽ ഉറങ്ങുന്നത് വരെ പല കാര്യങ്ങളും നിങ്ങളെ ചുറ്റുമുണ്ട് that produced by chemical engineers. So അതിലൊക്കെ നമുക്ക് സേവ് ചെയ്യാൻ പറ്റുമെങ്കിൽ, അതിലൊക്കെ എനർജി ഫ്രണ്ട്ലി ആയിട്ട് ചെയ്യാൻ പറ്റുമെങ്കിൽ that's the best thing. It will have a great impact. So that's the main idea of this design engineering training program, and also Netherlands is trying to attract the design talents from all over the world. So it's a nice opportunity for the people who are in masters or who are going to do their masters. I repeat again, because you get some money for that, you don't have to pay anything. And yeah, for the students who are bachelors and if they want to do their masters, actually chemical engineering is a major domain of many subdomains. So you can go to these subdomains or even more, depends on your interest. And also you can go to the core field that I mentioned in one of the slides. So that's all about it. But if you want to go abroad for the masters, if you're really financially sound, it's fine. But I don't really recommend people who really want to apply for the loan and all. Like, it's really a disaster. But there are some universities that you get education for free, of course. But again, you have to find your living expenses. You have to meet your living expenses. If you're really bright students of 9 point and all, like പല രാജ്യങ്ങളും ഇപ്പൊ ഡാറ്റ് സ്കോളർഷിപ്പ് ജർമ്മനിയും ഇന്ത്യയും തമ്മിലുള്ള ടൈപ്പാണ്. അതുപോലെ നെതർലാൻഡ്സിലെ ട്യൂലിപ്പ് സ്കോളർഷിപ്സ്, അതുപോലെ ഓരോ കൺട്രീസ് തമ്മിലുള്ള ടൈപ്പ് ഉണ്ട്. സോ ഇഫ് യു ആർ റിയലി ബ്രൈറ്റ് സ്റ്റുഡൻസ്, ഓൾവേസ് ലുക്ക് ഫോർ ദി സ്കോളർഷിപ്പ് and everything will be covered by the scholarship. Otherwise, we have good institutes in India where you can get your master educations, then you can really go for your PhD or PDM abroad without spending any money. Yeah, so maybe a question like, what does a chemical engineer do now? Because I was talking about 1900 or 1800. So first of all, you see the main source for all materials and energy nowadays, even now, is a fossil-based resources. We get it from oil and gas or coal and so on. But the problem, every day, നമ്മുടെ ഡിമാൻഡ് കൂടിക്കൊണ്ടിരിക്കുന്നു, നമ്മുടെ ആവശ്യം കൂടിക്കൊണ്ടിരിക്കുന്നു. നമുക്ക് ഒരുപാട് കാര്യങ്ങൾ മെറ്റീരിയൽ ആയാലും എനർജി ആയാലും. But what's the problem? The resources are declining because fossil fuels or the fossil resources, they form by ages. Like ഒരുപാട് വർഷം എടുത്തിട്ട് ഫോം ചെയ്ത fossil fuels ആണ് നമ്മൾ എക്സ്പ്ലോർ ചെയ്തിട്ട് നമ്മുടെ ആവശ്യങ്ങൾക്ക് വേണ്ടി. At the same time, there is an environment problem because these are carbon containing elements and we have the high temperature, high pressure process. അപ്പോൾ നമ്മൾ ഇതിന് വലിയ എക്സ്പ്ലനേഷൻ വേണ്ടി വരുമെന്ന് തോന്നുന്നില്ല. ഇപ്പോൾ കേരളത്തിൽ തന്നെ hit by floods in 3 consecutive years. കഴിഞ്ഞ 3 വർഷങ്ങളിൽ നമുക്ക് ഫ്ലഡ് വന്നിട്ടുണ്ട്. സോ ഇപ്പോൾ നമ്മളുള്ള പലർക്കും ഓർമ്മയില്ല അതിന് മുന്നേ എന്നാണ് ഫ്ലഡ് വന്നിട്ടുള്ളത്. സോ ഇപ്പൊ അതൊരു സ്ഥിരമായി, ഓക്കെ ഓഗസ്റ്റ് ആകുമ്പോൾ ഫ്ലഡ് വരുമല്ലോ, പിന്നെ കുഴപ്പമില്ല. അപ്പോൾ അങ്ങനെ സാധാരണ, സോ ദാറ്റ്സ് എ എഫക്ട് ഓഫ് ഗ്ലോബൽ വാർമിംഗ് ഓർ ദ ക്ലൈമറ്റ് ചേഞ്ച്, ദാറ്റ്സ് റിയൽ. സോ if people say it's not real, they're fake. So there is an alarming sign. So we have to do something. That's what chemical engineers, I think most of the chemical engineers are doing, either to switch to a renewable carbon feedstock, renewable and low carbon feedstock, I would say, because we should switch to a feedstock that we can renew. തീർന്നു പോകാത്ത വീണ്ടും വീണ്ടും പ്രൊഡ്യൂസ് ചെയ്യാൻ പറ്റുന്ന ഫീഡ്സ്റ്റോക്കിലേക്ക് നമ്മൾ പോകണം. Otherwise we'll run out of this, because this is true, it's actually decreasing and this demand is keeping on increasing. Last part, the more efficient process, because പല പ്രോസസ്സും inefficient ആണ്. ഇൻഎഫിഷ്യൻ്റ് എന്ന് വെച്ച് കഴിഞ്ഞാൽ നിങ്ങളൊരു 10 kg കൊടുത്തു കഴിഞ്ഞാൽ അതിൽ 5 kg യൂസ്ഫുൾ ആയിട്ടുള്ള, ഇപ്പോൾ 5 kg വേസ്റ്റ് ആണ്. അപ്പോൾ എങ്ങനെ 10 kg കൊടുത്തു കഴിഞ്ഞാൽ മാക്സിമം 10 kg യൂസ് ചെയ്യാൻ പറ്റും. അപ്പോൾ നമുക്ക് മെറ്റീരിയൽ യൂസ് കുറയ്ക്കാം, എനർജി യൂസ് കുറയ്ക്കാം. സോ വി ക്യാൻ ആക്ച്വലി കോൺട്രിബ്യൂട്ട് ടു ബോത്ത്. വി ക്യാൻ യൂസ് ലെസ് എമൗണ്ട് ഓഫ് റിസോഴ്സ് and same time we can meet the demand, and also it makes the environment cleaner because you'll be spending less energy. But in a nutshell, like whatever you do, make it sustainable. So that may be a new word, but I don't think so for the undergraduate students now. I think KTU introduced a sustainability, introduction to sustainability course in the first year of the curriculum. So that's the main idea. Whatever you do, make it sustainable. And I show you very quickly, because I'm running out of time, the projects I personally involved in with these their goals. So in the PDM, I work with the TNO, Center for Applied Scientific Research, but the CSR labs, Netherlands Applied Scientific Research Center. So we try to explore the process option to get biomass and natural gas. So because Netherlands or another Europe, or I think worldwide, they have the largest natural gas in a reservoir or the economy then depends on that. So people use natural gas for everything. Cooking, winter heat, using natural gas because they have abundant amount of natural gas. But the problem that in recent years, flood frequent earthquakes in the area due to large exploration of natural gas. So TNO and other institutes, they're trying to see substitute. They're trying to explore a substitute for that. So this is a substitute for that. So that's one of the projects. And the project I'm currently working in the cousins on presentation, cousins, we must try to integrate the microorganism or the living organisms, society, and machines. So that's what exactly we're trying to do here, because gas elements of gas industry of gas. Carbon monoxide, hydrogen elements. Microorganisms, organisms, they have to get some substrate. So microorganisms gaseous substrate, carbon monoxide and hydrogen consume. But the consume chamber produce useful chemicals and energies. In microorganism biology use chemistry, physics, maths, you can also use life sciences and chemical engineering. Chemicals and energy, microorganisms you see these are off gases. Pollution off gases in a product convert here. But the circular route on the sustainable route on tons of ethanol is produced by this method. Landsat and another company, and I couldn't include that in the slide, so you can Google it. So China, Europe, USA, already plants running on. They use this ethanol for transportation, aviation fuels, and other manufacturing things. So it's really very potential technology. And we are trying to increase the product spectra. They produce ethanol. So when we research main ethanol materials, energy of main materials, the chemical components of producing. That's what we are trying to explore here. So that's just an example. Then the second part of this event is the challenges in engineering educations. So I again want to take some technical examples from my universities. In our group, as I told you, like main dreamers and like process engineering side, I mean conceptual designs developing side. So you should really start at the end. Normally, for example, if you see this process that's a process route. But as a process engineer, we start thinking from the product, which product you're going to make, and in the product and the market value, is it competitive with others, and then applications. Let's say chemicals mask it has an application. Everyone is using a lot of masks now. So we think from the end side. So that is start at the end. I think then we come back to each step of the process, finally to the raw materials. So that's actually a proven technology that's more efficient. So we should really think the same in the academic environment in our engineering educations, because we should really think at the end where these engineering students are going to. And the second approach we have is to scale it down. The second approach, because in industry, as I said, like we start with an idea, labular identity, and then finally large scale production. So there is a scale up process. It's called scale up. It's a bench scale, and identity. You should really construct it in a lab scale setup. Then a pilot scale, a little bit larger. Then a demo scale, it's a small plant, but it's still like not really a large production, and finally to industry. So the problem with this, when you finish with the industry, so when you scale up, there is a problem because the conditions are the problem. So the solution for this we found, we should really scale it down, because you should really think about what happens in the large scale, because if we have computational tools പഠിക്കാൻ പറ്റും. ഈ ലാർജ് സ്കെയിലിൽ ഞാൻ ഇത് ചെയ്താൽ എന്തായിരിക്കും, ഞാൻ ടെമ്പറേച്ചർ കൂട്ടി കൊടുത്തു കഴിഞ്ഞാൽ എന്ത് പറ്റും അറിയാം. സോ ഐ ക്യാൻ റിയലി സ്കെയിൽ ഇറ്റ് ഡൗൺ ടു ലാർജ് സ്കെയിൽ. ആ ഒരു കണ്ടീഷൻ, ഈ നമ്മുടെ ഈ ലാർജ് സ്കെയിൽ ആ കണ്ടീഷനെ സ്മോൾ സ്കെയിൽ നമ്മൾ സ്കെയിൽ ഡൗൺ ചെയ്തിട്ട് എക്സ്പെരിമെന്റ്സ് ചെയ്ത് കഴിഞ്ഞാൽ we get an idea, okay, this would happen when you scale it up. So this scale it down approach should be there in our engineering education, because what happens in the academia, that's not at all, I'm not completely saying like not at all, like, but most of the things നമ്മൾ റിയൽ വേൾഡിലേക്ക് ഒരു എഞ്ചിനീയർ ആയിട്ട് പോകുമ്പോൾ നമ്മൾ അക്കാഡമിയിൽ ചെയ്ത പല കാര്യങ്ങളും ആയിരിക്കില്ല, അല്ലെങ്കിൽ നമുക്ക് അക്കാഡമിയിൽ കിട്ടിയ ട്രെയിനിങ് ആയിരിക്കില്ല അവിടെ വേണ്ടി വരുന്നത്. സോ വി ഷുഡ് റിയലി തിങ്ക് ദിസ് പോയിന്റ് ഓഫ് ടൈം, ഈ സമയത്ത് അവർ എവിടെയാണ് വർക്ക് ചെയ്യുന്നത്, ഏതൊക്കെയാണ് അവരുടെ ചാൻസുകൾ, അത് നമ്മുടെ അക്കാഡമിയിൽ തന്നെ റിഫ്ലക്ട് ചെയ്യാൻ പറ്റും. ഫോർ എക്സാമ്പിൾ, ഇന്നലത്തെ ടോക്കുകളിൽ തന്നെ ഞാൻ കണ്ടത് മൾട്ടി ഡിസിപ്ലിനറി ടീമിൽ വർക്ക് ചെയ്യുന്നത്, ടീം വർക്കിനെ കുറിച്ച്. സോ ഫോർ എക്സാമ്പിൾ, മൾട്ടി ഡിസിപ്ലിനറി വർക്ക് എന്ന് പറയുമ്പോൾ തന്നെ നമുക്ക് അക്കാഡമിയിൽ നമുക്ക് റെപ്ലിക്കേറ്റ് ചെയ്യാൻ പറ്റും. ബിക്കോസ് വി ഹാവ് ഡിഫറെന്റ് ബ്രാഞ്ചസ്, വി ഹാവ് കെമിക്കൽ എഞ്ചിനീയറിംഗ്, മെക്കാനിക്കൽ എഞ്ചിനീയറിംഗ്, ഇലക്ട്രിക്കൽ, ഇലക്ട്രോണിക്സ്. So we can really develop a project that a chemical engineering student can work with a mechanical engineer or an electronics engineer. So then they get a taste of it. Okay, I'm working with a mechanical engineer. We are thinking in a different way, but we are going to the same. We are going to a common solution. So we must scale it down, what happens in the engineering life to the academic life. So these are the two challenges I think we must think about. Start with the end and scale it down. And finally, I would like to ask, again, you cannot say anything. So the best chemical industry in the world. So if you have an idea, you can speak to yourself. It's okay just to be in the presentations. I would say that's a human body. Why it's the best chemical industry? Because same way, you get some raw materials, you're having some food. So what happens? You do some pre-treatment, you do some chewing, washing with saliva, crushing it down. Then it goes through a pipeline to the main reactor. So that's a main reactor system. So where the main A gives B happens, but it's only A and B, it also C. So there should be a proper separation. So we have the world's best separation system for both solids and also for the liquid your kidneys. So it's exactly what's happening in the chemical industry. So this is the best thing. So if you see, so that's about the digestive system. So in the chemical industry, we really need energy. Energy കിട്ടാന്ന് വെച്ച് കഴിഞ്ഞാൽ നമ്മൾ സ്റ്റീം അല്ലെങ്കിൽ വാട്ടർ, അപ്പം നമുക്ക് ഹീറ്റ് കൂൾ ചെയ്യാനാണെങ്കിൽ നമ്മൾ വാട്ടർ ഉപയോഗിക്കും, ഹീറ്റ് ചെയ്യാനാണെങ്കിൽ നമ്മൾ സ്റ്റീം യൂസ് ചെയ്യും. അപ്പോൾ അതൊക്കെ പോലെ തന്നെ നമ്മുടെ സർക്കുലേറ്ററി സിസ്റ്റം, നമ്മുടെ ബ്ലഡ് ശരീരത്തോട് ഫുള്ള് ഓടുകയാണ്, ഒരു പൈപ്പിംഗ് നെറ്റ്വർക്ക് ഉണ്ട്, അവർ വെയിൻസ്. Then it supplies oxygen and takes carbon dioxide, it supplies other minerals, everything. And same way respiratory system. So it's all supportive system. And there's also a control system, as I told you, like you should control the process. Temperature fix reactor temperature. If you go out of that window, that would cause some problems. So same with the nervous system. If something goes wrong in your body, suddenly you get a signal to your control system, that's your brain. It sends a signal back to that respective organ to take an action. So the same way, there's nothing different. So I always believe that engineering is understanding the God's magic of creation, then apply it for the well-being of the society and the environment. So we should always learn from the ideal situation. We call it ideal or equilibrium as an engineer. So this is what it is. And the final question to you, maybe, or again, you can speak to yourself, who is the best engineer, the best chemical engineer in the world? If you answer this, now I cannot hear you, but still I offer you a free internship with that best chemical engineer. So for the answer, I give a clue. Just because of pandemic, you don't have to go out of your home. So just see within your home. So where is a production site at your home? Your production site at your home is your kitchen. And who is the best chemical engineer? That's our mother. So she does the best chemical engineering. All the mothers, I don't know how, but God gave them some sort of ability to do a chemical engineering on a daily basis multiple times. For example, she wants to prepare fish curry, very nice fish curry. What she has to do, she has to get some raw materials, the fish and other ingredients for that. And what she does some physical treatment, pre-treatment, where she has to cut the fish, she has to clean it, wash it and cut it. And she has to prepare, how you say, after that, she has to put everything in a pot, it's a chemical treatment steps for some time. She keeps the temperature. She actually monitors the temperature. She knows how much fuel to be filled in, everything. And she keeps on evaporating the water. That's the final steps to get your final products. So is that the only thing she does? She does in the kitchen, because we talked about the professions in chemical engineering. It's a heavy rain. I'm not sure if you can hear me well, but still, she does the research and development, because she has to really think about. She's very advanced, because she starts with the end. She really think, okay, what my husband or the kids, they like, so they found the product first of all. Then there's a different way to make the fish curry. So she developed different options. Then she decided, okay, I'm going to do it. She has to develop an engineering design. Okay, then it's size cut. So she develops everything. And finally, there is a cooking, that's a construction and erection. So she puts everything on the stove and she keeps monitoring the temperature. She keeps filling in the fuel. So she's monitoring it well. And also she does the sales, because when she prepares this curry, what happens? Like you come up, then she has to convince you, okay, this is something that's good for you, then shawai and shawam. They do chemical engineering every day in life. So my suggestion during this pandemic, I'm giving a free internship to help your mother in the kitchen. Then actually you can learn a lot of chemical engineering. So that's an internship free things for you. That's a plus point. And finally, this is the last slide. So this is first thing. It's an applied science, chemical engineering, where you can apply all the sciences that you learn from the schools. That's a basic always. And the job opportunities are really enormous, especially if you go abroad, because as I said, like it started with the Industrial Revolution. The Industrial Revolution mainly happened in Europe and US. So there are a lot of job opportunities over there. It's not only in Europe and US, in India and the Middle East. Oil field, Middle East, job opportunities under. But higher education first. If you really think about higher education, keep everything else away, because you have a lot of options for high studies, and there's a high demand at this point of time for the highly skilled chemical engineers. So you really have to find your interest in BTech, then go for a specialization in masters. Then you find more interest in it, then go for your high studies in PhD or PDM, again without paying any money. Then going abroad gives you a different outlook. Chemical engineering, but my advice, please come back. We can do a lot of things here as well after you get that perspective. And they're very good and experienced chemical engineering institutes in Kerala. So I think if you talk about the experience, the first engineering institute was in Government Engineering College, Thrissur. And after that in TKM College of Engineering, I think the chairman of TKM itself, he's a chemical engineer. He got his degree from Texas, I think, in US. Then we have my college, GC Calicut, then NET Calicut, I think, started in 2006. So these are the 4 government sector institutes. And there are other private institutes that started some years ago. Amal Jyoti, St. Gates, Tom's College, Cochin College of Engineering. And as I said, like there are also other options. You can go for biochemical engineering in SUT, Papanangod, like it's a government self-finance. Government controlled self-finance college. Then also you can go to Mohandas for biochemical engineering. So there are a lot of options for the studies in Kerala. So it's one of the best branches. Thank you very much. That's all. Am I still online? Because I'm not hearing from you.
So thank you, Hanif Shijaz.
Yeah, thank you very much, sir, for your presentation.
Yeah, please.
So we are waiting for. I think there is no question answer question found from the chat box.
Okay.
I think
that was so clear to everyone. So it's good.
Yes, sir. So with this, we come to the end of this lecture. Then we will move on to the last session of today lecture. So now I invite engineer Radhakrishnan A, who have wide experience in aviation for the past 40 years. So he completed BSc Electrical Engineering from Kerala University, Thiruvananthapuram. Then he has vast experience in the world-class organizations such as Air India, Malaysian Airlines, Honeywell Technologies, Jet Airways, Kingfisher, and Airworks India. So presently, he is engaging with a seal to help youngsters induction into aviation domain with the experience gained in his professional experience. So with this brief introduction, I invite engineer Radhakrishnan sir to address our participants. Welcome you, sir.
Hello. Hello, good evening to everybody. And let me welcome you all to this presentation. But however, the time has gone too far. So may I ask Mr. Shekharan Menon from Edge University, CEO of Edge University, to give you a brief sketch of what Edge University is trying to do. Can I do that?
Yeah, yes, sir. Yes, sir.
Shekharan, are you on?
Yeah. Good evening, everybody. I know we are almost running probably 1 hour 5 minutes behind the schedule. So I'll just take about a couple of minutes to introduce what Edge University is trying to do. And in fact, I liked the usage of Mr. Shijaz. He used the word of the students getting into a pressure cooker and coming, almost coming out after 4 years. Interesting analogy. So when they come out, they come out with a very strong foundation of theoretical knowledge, right? I mean, that's what all our engineering colleges do a wonderful job on. But what is a bit difficult, or a bit of a painful scene is many of these students, when they come out with very good academic records, they find it a bit difficult, or maybe sometimes extremely difficult, to get into the right industry. For example, somebody who does aeronautical engineering getting into aeronautical engineering, or a mechanical engineering getting into mechanical engineering stream of oil and gas or whatever, right? So when you look at that, what you see is it is not their academic records or the academic background that matters. What is coming in the way of they getting into their chosen field of work is the industry orientation or the industry knowledge. And in fact, I have seen this because I've been working in the industry for about 30 years before I became part of Edge University. So what we figured out is, while colleges and universities do a fantastic job of imparting that theoretical knowledge and making sure that the foundation is built, we need the support of industry. We need the support of people from the industry to give them that industry orientation. And Edge University as an organization took that step after about 2-3 years of detailed studying and planning back in 2019. And we are very, very, very happy to get associated with people like Mr. Radhakrishnan and many other people who spend all their life in specific industry. And having spent some time in the industry, I'm convinced that students, when they come out of this engineering college, for them to be ready for the industry, talking to people like Mr. Radhakrishnan or Mr. Sharma, who is part of our organization, who has spent their lives in the industry, is going to be a great, great experience. And what we have done is, it is not going to be possible for everybody to talk to them. So we put all of them in the form of a training program. And what we're trying to do is we are trying to provide this training program to all these engineering graduates who are coming out, so that we make their journey from university to industry a smoother one and not a shaky one. With that, let me hand it over to Mr. Radhakrishnan, who spent all his life in aviation industry, and talk about aviation industry, the job challenges, and what students need to do for them to make themselves ready for the industry. Thanks, RK sir. Over to you.
So let me welcome all those who are present. At the outset, let me convey our sincere thanks for giving this opportunity to address this august forum of academia and students wishing to venture, concentrating on a career path rather than an education degree. So can we launch that presentation, please?
It is on. RK sir, it's on.
Okay. Now, as a self-introduction, I would say that I am armed with a BTech degree in electrical engineering. I entered this career of aviation in 1970 after the electrical engineering degree. with absolutely no knowledge on what is going to happen to me in the field of aviation, because my degree is electrical. I had the opportunity to work for 50 years or almost about 50 years in this field of aviation. I'm carrying that knowledge which I gained as a professional working in the field more than an academician. But I have got a lot of stories to tell about what happens in aviation and how it can be transferred to the next generation of aeronautical engineers. I'm ready to share my experience with the people. So aviation industry gave me all this opportunity to be a part and parcel of revolutionary changes in the concepts to activity to operations. Slide, please. Forward. Okay. Now you can see a cockpit of 1970. That was 1970. Boeing 707 was the aeroplane used by Air India for long journeys, for long haul flights from Kerala, from Bombay to Delhi, Bombay to London and back, or Bombay to US. We were using that aircraft. Now look at the cockpit of that, which is there down here. Looking at only one part of the panel, you can see that there were a cluster of small tiny indicators which was showing the actual performance of an engine. And this performance, the pilot was expected to clearly watch it out and see that it is not going out of the way. So it was too much of a strain for the pilot at those times. And unless they follow that, it was not possible to control the engine, and it might go into crashes and safety issues. But today, just see above that, this is a Boeing 737 Neo or Boeing 737-800 aircraft. With a lot of all that clustered instrumentation has now come to only one LED display, LED display, which will give the pilot only what he has to see. Everything else is controlled by the computers on the aircraft, on the engine. It's called EEC, electronic engine control. And electronic engine control will take care of everything except for the pilot's input of a throttle. He puts the throttle in a particular position, the environment will be changing, everything will be changing on the aircraft, but the pilot hasn't got to do anything more than select it to the right position in the beginning. Everything else is handled by the computers. So the technology has changed. The first technology where sensors were directly giving the information to the computer, to the indicator, whereas now we have the sensors, informations are digitized, controlled by engine control, and then being presented to the pilot whenever there is a mistake. On that particular indicator, he gets not only the information about the aircraft engines, but he also gets the information called the crew alert warning system. If there is something wrong, he will be alerted what exactly is the problem. And he is also instructed in that system by that, now you take this action to get over this problem. So aeronautical engineering has become highly sophisticated. That sophistication calls for a different model of learning. Of course, I learned from my basic electrical engineering degree, and it was sufficient at that point of time. Today, that is not the criteria. So what we learn from the college is still based quite a lot on the old technology, not in the present technology. Now, in order to explain this, I would like to take a small example of a burger. Can you click on that burger on the right side, please? Yes. When a person goes with a hunger to eat something in the burger home, what he believes that he is already filled with whatever is required for making a Big Mac. Whereas here now, what we are getting out of the college is just the reality is just 2 buns, nothing more than that. The rest of it has to be filled in. So where do you get all the fillings? These fillings have to be supplied by the people who are aware of what it is, what should be the fillings. And that is why it is necessary that university education at this level need to be supported by field people, engineering, the people who have been struggling their days to filling up all these amenities. Shall we go to the next one? No. now the burger is fully ready and you can have it. But the technological journey has made so much of a change, and the people who are coming out of the college, they cannot identify what exactly are there on the aircraft. For example, what you see in the picture now is a fuel draining system or fuel draining, water draining from the fuel tank. A canister which is connected directly to the fuel tank bottommost portion, and they take out the fuel and see how much of the water content. If the water content is too much, you know what it is. It means that it cannot produce the energy which is required out of the engine. So this is one of the common thing which is used by an aircraft engineer, but or a mechanic. But the people who are doing the studies in the college, they may not know about it. The importance of knowing fuel quantity is the engineering graduate is fully aware. If there is water in the fuel, it may not take off at all. And it has happened in India itself. 4 engines shut down during the takeoff run. That was because there was too much of water during a monsoon season in Bombay. Think about it. Can we afford that? We cannot afford it. Then we have to know all these things, what we are going to work as. Can we go to the next slide, please? Look at this instrument. Just a sheer small pin. What is it for? Where is it used? Yes, it is used in a very, very critical area. After the aircraft is landed, these pins are used as a rig pin or are not allowing certain things to happen when the aircraft is on ground. Next. Now you see a picture. As an engineer who is coming out of the college, if somebody is asking you, what are you seeing in this picture? It may be very difficult. It may not be the right thing to ask him because he has not seen that before in the college. So the technology has improved and we have not improved in that level. Next, please. Oh, I forgot to mention to you in the previous slide. Basically, it is an approach of an aircraft for landing. And the approach of the aircraft for landing has to be clearly visualized. If it is a visual flight range, he is expected to see the runway in a most critical way and take decisions, right decisions at the right time. This instrumentation is called something called PAPI, P-A-P-I, Precision Approach Path Indicator. Now, if he does not follow the precision approach in the path indicator, what happens? He might create a Calicut incident. So on this panel, I will show you what is so minor as a locking wire between the nuts and bolts. This nuts and bolts locking wire and the way in which it is wound is very important. Otherwise, that nut may be lost in the flight and it will go to big accident. So all these are something which we have to realize before we venture into the career of aviation. Next. Slide 3, please. Here you see a small tiny hole on the passenger window on the right, on the side where you are sitting. You can see a small tiny hole which is not noticeable unless you look at it. What is it doing? It has got a very important function. It is trying to equalize the pressure between within the aircraft and outside the aircraft. And all aeroplanes are designed for a particular pressure differential. And that pressure differential is not maintained, it will crash. The windows will crack. So this is doing a pressure differential, maintaining the pressure differential between the inside of the aircraft and outside just the next pane. The outer pane is expected to take the pressure differential load, not the inner pane. So this is what is being done in this. Next. So how did this? So many things are being managed. So many things are managed by in an aviation industry. So may I explain all these things? See, you can see that there are so many departments only other than maintenance only. People get a knowledge that, or they think that aircraft maintenance engineers are sufficient to maintain aeroplanes. No, it has got so many departments. I'm just giving a brief explanation of some of the departments: protocol management, engineering quality, power plant, technical services, and airframe. Technical services, cabin maintenance. Technical services, plant, power plant and APU, aircraft check packaging. So like that, there are 17 issues which have to be properly controlled and maintained. And that is the biggest job for an airline. An airline, any airline which is operating with more than about 10 airplanes should have departments for all these areas. And all these have to be handled by people who are technically very sound and who can predict by looking at the performances, who can predict this. Are we on slide number 8 now? Please move to the next one. Now you can see two persons managing. This is actually a video being presented. So I have given a this in that page. I have given as in this thing link. Please, I because of the time loss, I don't want to explain it and spend about 5 or 6 minutes on that. So I expect I will request all the participants to take up this link, open it up and see what happens during this time. Okay. So to become an airline engineer, you can take all those methods. So next. Now what can be, do not open that, please. Please stop, because we do not have time. It may take almost about 6 to 8 minutes to complete that. So now our question is, the engineers are not getting job. Why? We should be aware that what is happening around us. We should be prepared ourselves. We should gear up. We should learn. We should upskill. We should know, and we should grow along with the system, for which you can watch out all these videos. Now, what can be done to improve this situation of the people coming out of the college? What can be done? Let's go to the burger story again. Let's go to the burger story again. I know you are searching for spinach toppings, tomatoes, etc. Next. This is exactly what Edgeversity is trying to do. We will provide you all this.
Go to slide 9.
Yeah. Can you go to the slide 9, please?
Next slide.
Next.
Click.
Yeah. After getting BTech degree, the engineer is capable to do work with at least 6 months or 1 year training. This is the burden on companies, because they cannot afford to spend so much of money on training them. So they expect that people should be at least adequately informed about the jargon and the language which is used by the aviation engineer. That is what we can give. There are almost about 4,000 colleges producing so many of the engineers. Now, what is the differential factor? You have to have a differential factor of the basic knowledge of what they are expected to do on the line. Almost about 10 to 15 lakhs of engineers are available. So to take it, they should be skilled with this basic information. And that is what Edgeversity is trying to give. Can we go to the next one, please? The technology has changed drastically, but the syllabus of the colleges is not changing in accordance with that. With present technologies, how can we survive? These students coming out of the college should be armed with some information which can be taken out of the engineers. Now the gap between the engineer on the field and engineer in the coming out of the college is not very big. It's a very small thing. Engineer coming out of the college, because I have been associated with Nehru College for almost about 4.5 to 5 years, where I have found that engineers who are in the college, they are excellent. They can understand very well. But only thing is that when they go to the industry for interview, they find it very, very difficult to answer questions. Can we go to the next slide, please? So here, what we can see, we have graduates, we have colleges, we have got industry and government supporting all that. And that actually has to collect together. They have to make a handshake between all these departments. If we make that handshake, then they are employable. And that employment opportunity has to be created by this handshake. And that is what is expected of them. How can we do that? There are so many airlines and MROs. They can employ you, provided you can show them that you have the adequate, basic knowledge, not adequate knowledge, basic knowledge of certain factors which are required to be known. Can we go to the next one, please? Now, government is trying to give a lot of scope for aviation, because aviation is not going to go down. With the number of people who are presently in India and all over the world who need to travel with the with the necessity of going out to find jobs and otherwise a living, people are moving, and this cannot shut down within a matter of 1 or 2 years just because of a pandemic. We have to create a reserve of people who are ready to take over the job, and global requirement is that they are looking for people from India. Definitely, Indians have got the brain and acumen to be the best in the lot. Here, there is some small difference of opinion is that what is skill? Skill in aviation is basically ability to think beyond books. They have to understand what books to refer, how to take decisions. And that only an engineering graduate or people who have been specially trained for becoming aircraft engineers, they get that training. But how can they prove it to the to the engineering faculty of MRO or airline? And that's the challenge which Edgeversity is taking. Let's go to the next one, please. See, these are government policies which makes the field right for getting position for aeronautical engineers and AME graduates. But are we using them in the right way? Next, please. Now look at what Edgeversity presents to you. You can see the people about. Almost all of us are 40 to 45 to 50 years in aeronautical engineering, and we have been working together. And what have we done? We have been a part and parcel of the development of from that iconic old type of cluster indicators to the present day management of aircraft by cloud, fly by cloud, fly by wire, then fly by cloud information, etc. Lot of things are related to the industry, to the technology improvement, and that technology improvement, to understand and work along with it, we require people, and government and these things are ready to take this thing. And Edgeversity Systems is a provider of education technology platform which is focusing on the employability of young engineers through courses designed and curated by the people here. You can see me. There is a German engineer who is supporting us in this venture. Then I am there, and my colleague, Mr. Ashwini Sharma, who is an aeronautical engineering AMAESI president in Bombay. Then the other people like Sumant and Muralidhar. We have lots to speak to you. But how do we get opportunity? Because present criteria on the colleges are that we are not MTech. We are not MTech holders, but we have adequate information and knowledge which we have acquired and picked up during our career. Now, do you want to waste us? Not you make use of us. If you want to make use of it, please connect the young engineers who are coming out of the college with us. We are ready to help you. We are ready to serve you. Can we go to the next slide, please? See, look at the aircraft. An Airbus 300 aircraft and Airbus 320 aircraft. Technology has changed, but have we changed? Remember, the technology calls the shots. You should not become a slave to the technology, but you should be able to master the technology. To master the technology, what you require, you have to be within it. And that information is what we are carrying with us. And we will be able to give that to you. Next. And Edgeversity is creating that bridge for you. The academics, when you are coming out of the academics, you can be trained by using a audiovisual program and platform-based education. And this platform-based education is being curated by people like us. We are there to serve. We are there to help you. We don't have to serve for that purpose. We have to help you. We have a zeal to do that. Please give us an opportunity. That's what I can tell you now. Next. Just for your information, just look at that the kind of a syllabus what we have created. This syllabus is covering 14 aspects, starting from introduction of why you have to get this information, then different departments in a major airline, how parts of the aircraft can be controlled, aircraft flying principles and theory of flight, and many things which are related to the safety aspects of it, navigation systems and navigational aids, regulation practices, regulatory agencies, aircraft maintenance documentation, quality and safety practices, aircraft maintenance as a concept. It's a concept. Aircraft maintenance is just not fail and fit. It is not fail and fit now anymore. We have to analyze the data streams available all over the aircraft. That big data has to be analyzed. So there is a big data aviation in aviation, those to be analyzed by people who are quite capable of doing that by analytical method. Material planning. Each of the components and components fitted on the aircraft are so expensive that if you don't plan it, that will be the surest way for the airline to go down. So we have to plan the requirement of this thing, and there are new main methods of how to handle it. One of that is aircraft leasing and parts leasing. Another thing is aircraft ground handling. How to handle the aircraft when it is on ground. Aircraft cabin attracts the people. It has to be most comfortable for the people, and we have to spend. The airlines have to spend a lot of money to ensure that the passengers do not get bogged down and do not get bored within the aircraft. For this latest technology, using the satellite communication and everything else is being used up. So that is where you can get employment in any one of these departments, 14 departments. And over and above that, how do you handle an aircraft? That is one of the other things we are giving. And what we are trying to do is that we will create a specific course of 1 or 2 months, whereby the person coming out of the college will be given an introduction to a close introduction, a familiarization, detailed familiarization of the latest aircraft like Boeing 737 MAX or Airbus 320neo. All these are possible. So that is what we are trying to do in Edgeversity. Next, please. Now, here we have a video for which also we can give you the link. You can go and see that the principles what you have learned in college about how Bernoulli's principle helps in getting lift on the aerofoil, how the aerofoil is magnified and shown to the people. All these things are being shown through a audio, video, AR, VR presentation. AR, VR means I am sure the young generation know augmented reality and virtual reality. We create that kind of modules, and they are very expensive, but we create that and invite you to go through that to learn the principles, basic principles onwards. Next, please. Yeah, here you get an engine. How does the engine work? That is given in this particular this thing, which you can click and you can find out a real feeling of how the engine works. How does it happen? How the air path is compressed and then it is again ignited to get more pressure, more movement on the turbine. So this is also, all this you have learned in the college, but what are the parts along with it? That is what you are going to learn here. Next, please. Benefits of online. We are now doing this as an online education, because the benefits of online education as the main thing is that you don't have to travel into another place. No travel to the training school, no waiting for the new batch to start, no need to locate a PG, paying guest accommodation near the institute. What do we get by the course? Most answers to the latest technology and information. Simple understanding with answers and analysis on the happenings of the latest issues. What, where, why, when, who, and how. This is the famous 5 wives and 1 husband theory. You ask the 5 W's and 1 H, you will get the answers for everything. And we will teach you in that fashion. And specifically, I will tell you, please note that we are here to help you. Let us analyze the difficulty with a practical approach. We will prepare a syllabus for you. We in this case, we means the people who have experienced it for the past 45 years or 50 years. We are the part and parcel of this development. We know it from the clear mechanical aircraft where you move a control wheel and the cables and drums and quadrants will move the control surface and you fly the aircraft. It is no more that way now. It's all fly by wire. You send the information through a wire in the digital format. So the digitization, all these things you have to learn, and how is it managed. All these informations are available on the aircraft in something called the flight data recorder, quick access recorder. Now, this information, how to analyze it? That is why we need people The airline engineering requires people who have the analytical and logical ability. Next, please. So Edgeversity is trying to do this, give this help to you. Skill does one most important factor that you have to understand today is that skill is not more practical and physical. It is more of an analytical skill, analytical and logical capability. Optimize the resources and time, which will give the returns to the airline. And airlines are looking for that kind of people. It's not possible for them to go on taking all these people for this purpose. It was possible in 1970s when I went there. That is how I got trained as an aircraft engineer. It took about 7 years for me to become an licensed aircraft engineer with graduation engineering with me. But today there are people who are coming out of the colleges with graduation and AME training. Now, so if you can give us the opportunity to meet you and give you this information, you are ready for the airline engineering. And now look at one more thing. I will just ask you a simple question. Even aviation aeronautical engineer comes out of the college and he is asked one or two small questions to understand whether he can visualize the problems on the aviation. Where do you set the flap for takeoff or landing? Where do you set maximum flaps? And if you as an aeronautical engineer and gives an answer that you put maximum flaps for takeoff, because that is very heavy and aircraft has to make more lift. That is absolutely wrong. And that is what you are not getting the information, because you have to be along with the engineers and operation pilots, etc., for getting this knowledge. A similar was the information where, have you heard about something called ETOPS? ETOP means extended twin engine operation. So extended twin engine operation is that certain operational routes are best for the aircraft to operate. Now, if you do not get the flight level, you will not be able to fly. And if you fly below that flight level or more, you are going to lose more energy, more fuel. So all these things to analyze this, you require, once again, I emphasize and put to you that the airline industry requires good graduates. And even in the AME institutes, now DGCA has agreed that AME institutes can be taken to the MROs or somewhere where they can get a practical training in accordance with the regulations. Regulations stipulated for 147, car 147 training is that they should at least go through 287 hours of training in an MRO or an airline. But before you go there, unless you know what you're going to see, since you have not seen from the college, most of them have not seen the aircraft and that to the latest aircraft. If you have the knowledge of that and then go there, I think you will not have any problem. Then you will be able to accumulate that practical experience what you require on the OJT. OJT is a primary thing which is required, but before you go to OJT, you have a knowledge of what an aeroplane is, what you're going to see and how you're going to see. So what we suggest here is that if the airline industry and institutions come along and are ready to accept people like us who have the zeal and zest to go on giving them this knowledge, because that is what I have got from the society. I want to give it back to the people below me, the people who have come for training. Give us an opportunity, we can do that. Similarly, the DGCA can also do that. The 287 hours of training, part of it, at least 40 to 50% of that can be done on an online platform. So we can use the MOOC platform, that massive online course, which can be used and we can certify that. And that will take them much easier to walk into the industry. This is what I can tell you. Now, I think let me stop here because the time is too much lost. So I could not do it more fair. Real time spending on this because of the time constraint. I hope people have understood what it is and people can contact us on this. Next slide, please. The Edgeversity platform, and you can get more about that. Do not be under the impression that it is going to be very costly. It is considering the amount of information which you are going to get at home. You don't have to move anywhere. It is it will be substantially very low for getting that knowledge for you to get accustomed or acclimatized with the airline engineering. So I wish all the best to everybody, and let me thank once again the organizers for giving me an opportunity to speak to you, because this is my dream. I wish to do this for the next generation. Please help me. Thank you. Over. Shall we close the session?
Yeah, thank you, sir. Thank you very much. And for your valuable presentation, the organizers, there is the educational activities and the strategic initiative of academic engagement. Really, thank you. Thank you very much for the session. And I think it was very useful. And this video will be available for future viewing also. Thank you. And
sir,
we
would
should
like
cooperate in future also.
Sir, I have one more request to you. Please do send this to KTU, Kerala Technical University, and say whether they can consider this course which you are giving. We are ready to give. We are ready to present it to KTU, and whether they can think it as a project work or maybe about a MOOC course, where the students can get credit points, and institutions can also think of adopting this style of education whereby their students are going to get employed faster. So if institutions are ready to run along with us for this course, it will be the best thing what we can do for aeronautical engineering. Over.
Yeah, yes, sir. We will check and revert. Thank you. Thank you very much.
Okay, sir. Thank you.
Yeah, thank you very much. Balu?
Yes, sir.
Yeah, I think we
Yes,
can
sir.
close. Yeah, we can close the meeting, and thank you all for the support, and thank you all the participants and the speakers for today's session. And we will meet again tomorrow at 4:30 p.m. Thank you. Thank you all. Please join us early tomorrow also. Thank you. Thank you very much.
Thank you.
Okay, thank you. Thank you, sir. Thank you.
Yes, sir. Okay.
Yes, sir. Thank you.
Yeah. Okay.